Good morning, ladies and gentlemen. Welcome to the HAICTA Session 6 on digital tools, crop and tree production. We are running a very tight schedule here. You only have about 10 minutes per presentation. I will be quite strict keeping you to that time. So each presenter, please be aware of that and don't overrun. The first presentation is by Ms. Mariana Copagna on data assimilation of LIA improved crop growth modeling. Please come to the podium and give your presentation. Thank you very much.
The green one? Okay. Now you hear me. Good morning, everyone. I hope that you are awake. I'm Maria Copagna. I'm data scientist at the Bioscience Institute, and today I will present you the research topic on the data assimilation of LAI, improved crop growth modeling, where we compare the in situ measurements and satellite estimations. So this is joint research between Wageningen University on one part and the Bioscience Institute on the other side. And actually two groups from the Bioscience Center for Biosystems, they did the data collection, and Center from Information Technologies, where I came from, and we did the data methodological part. So I will speak today a little bit about data acquisition, crop growth models, especially WOFOST, data assimilation technique, and I will conclude with the results. And so the experimental part is conducted in Serbia on the two fields, 28 hectares each, cultivated with soybean and maize. The fields are divided into 20 management zones based on the multi-year average NDVI values in previous years. And these 20 zones, 12 zones is chosen based on the variability. And you can see on this figure here that we have 6 zones per each crop, approximately about 1 hectare each zone. And the first part is the soil sampling, which is done in March before planting, and the planting was on the 27th of April, and once again in September after the sowing. Further, we have collected the data about the LAI, leaf area index, using the measure. You can see it here on the picture, and it is collected biweekly on site for soybean from V4 stage, and for maize from V6 to V7 stage. Also, the weather station is put on the edge of the field, and it's used for collecting the data about the amount of the rain, air temperature, humidity, wind speed, direction, and etc. And also, we collected data about sentinel images for the corresponding time points. Regarding the yield, it is collected using the harvest monitor, GPS equipped, and collected data is averaged per each zone. So the idea of this work is to create digital twin of a crop, and it is done using can be done using the crop growth models. In this case, we use the WOFOS, which is developed by Wageningen University, and a digital twin can be created by integration of real-time measurements using this data assimilation technique. So what is WOFOS? WOFOS is a dynamic model that simulates the crop growth with a temporal resolution of 1 day. And in the WOFOS, there are 3 levels of crop growth. potential limited and reduced. And in this case, we use the water limited because of the environmental situation on the field where we have water scarcity. And regarding how we estimated the yield, we use the total weight storage organs in kilogram per hectare. So in WOFOS, there are 3 groups of model parameters: crop parameters, soil parameters, site, weather, and agro-management parameters. And all these parameters need to be imputed in the model before the model can run. So one of the challenges is how to combine all these data from different sensors that they have a different spatial and temporal resolution, and how to do that in a harmonized way. And the second challenge is related to estimates of the uncertainty of the variables. So to overcome the last challenge, we use data assimilation, which is technique for estimating variables related to the crop growth. And the data assimilation is commonly performed using Kalman filtering. And the idea of Kalman filtering is to do sequential update of the model state by using the previous state and the estimates of the observation on the field, and also the associated uncertainties from a previous time step. And in our case, we use the ensemble Kalman filter method. So in our work, we investigated the performance of WOFOS model after data assimilation of LAI by using 2 different estimations, one of the on-site measurements of LAI, another one using satellite images. And we adjusted the model state based on these values. So the uncertainty is observed as standard deviation of the LAI of the satellite images and an LAI of the on-site measurements. So the data assimilation is performed using ensemble Kalman filter with 50 ensemble members, and we varied the total initial dry weight and lifespan of leaves as 2 variables related to the leaf, and we assume that these 2 variables have a Gaussian distribution. So here are the results for one zone of soybean on the left, and another one for the maize on the right. And you can see the influence on the data assimilation when the model starts to increase. So the y-axis is the LAI, and you can see how the data assimilation turns the model on the track by using the observed values. On the upper figure is using the observed on the field values of LAI, and the other one is using the satellite estimation of LAI. So here are the results for all zones for both crops. On the x-axis is the field measure yield, and on the y is the simulated yield. The red dots are data assimilation using LAI on site, and the blue ones are estimation of the yield using data assimilation and satellite LAI, and the black one is without data assimilation. So these are the results for all zones, and here are average results across all zones. So you can see here that clearly data assimilation improves the estimation of the yield in terms of both mean absolute error and roots square mean error. And for soybean, the results are as expected, because there is more improvement by using the on-site measures of LAI, which is more precise technique than satellite. But for maize, we still have the maybe non-typical results. So regardless, this study demonstrates one successful application of the WOFOS, and experimental work of the soybean is generally important because the WOFOS is not validated much on the soybean. So that's all. Thank you.
Thank you very much. Do we have any questions? Yep, go ahead.
Thank you, Maria. Very nice presentation.
Well, hold on, just to get a microphone.
I think I can be heard. Oh, you're right. Thank you, Maria. Thank you, Maria. Very nice presentation. Actually, you remind me what I was doing 40 years ago. My master thesis was on validating glycine, a dynamic soybean simulation model. I will share it with this later on with you. I'd like to. Quick question. Can you go back to the slide? You show us a little instrument that measures LAI.
Okay.
I want to make sure that this measures LAI or...
No, I cannot.
Don't worry.
Yeah.
Relative leaf chlorophyll level. Is it a small instrument?
Yeah, the small instrument.
You clip it on the leaf
Yeah.
and you measure the LAI with this instrument.
Yeah. That's the part that they did the... I didn't think was included in that part, but yeah, you clip it. It's a new
I will
developed
discuss
device.
some issues on this instrument later on. I don't want to take the time of the audience.
Okay.
Let me talk to you in a coffee break. Thank you.
Thank you.
Thank you very much. We now move on to a remote presentation by Mariana Diamantopoulou on machine learning model exploration for underbark tree bole volume estimation. Maria, are you there?
Yes, I'm here.
Thank you very much. Please
Hello.
Go ahead.
Okay. Thank you very much. First of all, I would like to introduce myself. My name is Maria Diamantopoulou. I am an assistant professor in School of Forestry and Natural Environment of the Aristotle University of Thessaloniki with specialization in forest biometrics. And I'm going to present you the paper entitled Machine Learning Modeling Exploration for Underbark Tree Bole Volume Estimation. Allow me to start with a small introduction about this subject. Wood volume and wood biomass is the most critical piece of information regarding the sustainable forest management so as to ensure the multi-functional role of the forest. A tool to this direction is modeling of features of trees such as total tree height, form height factor, total volume, etc., so that an estimation of the yield of the forest in financial and recoverable goods is possible. The goal of this study is to accurately estimate and predict the underbark tree bole volume of pine trees using field measurements that are easily obtainable. For this purpose, two distinct machine learning approaches were employed: the probabilistic Gaussian process regression, the GPR model, known for its effectiveness in handling noisy continuous data, and the random forest regression technique, an ensemble learning algorithm that enhances overall performance by combining the insights of multiple models. Due to the difficulties raised by the irregular shape of the tree boles, the accurate estimation and prediction of their volume and biomass production is receiving much attention. For many decades, despite its limitations, the regression modeling has been widely used in forest research by providing solutions both to the forest research and to the forest practice problems. Lately, the effectiveness of the machine learning techniques in the field of environmental modeling is also examined. Here in the transparency, we can see the location of our study is the suburban forest Seixou of Thessaloniki, Greece, where the ground truth data was collected. Upon the completion of the measurements, a sample size of 999 measurements was obtained. Systematic sampling was used to ensure that all different site classes were represented. The measurements included in the data set were the diameter at 0.3 height from ground and the diameter at 1.3 meters from ground, both measured by Finnish caliper, Diameters at 1 meter height interval above 1.3 meters measured by Spiegel scope, total height of the sample trees measured by Blumel-Ice hypsometer, and bark width measured by the Pressler's gauge. The underbark ball volume was calculated using the Smalian's cross-sectional equation shown in the transparency. Our available data set was divided using random numbers into two distinct parts: the sample of the feeding data, which constitutes the 7% of the total data, and the testing sample, which consists of the remaining 30% of the data. The testing sample was used for exploration of the predicted ability of the constructed model, while the feeding data set was further divided into two parts using the k-fold cross-validation methodology with k equal to 5, and used for the choice of the best model. A few words about the Gaussian process regression. This approach incorporates prior knowledge through kernels and provides uncertainty measures for predictions. GPR model is characterized by the mean and the covariance of the prior Gaussian process, along with the kernel that defines the relationship between two observations. In this context, we have used the kernel radial basis function shown in the transparency. A few words about the random forest regression technique, which can be used to solve the estimation values of continuous variables. This algorithm constitutes an ensemble supervised machine learning model, which makes use of the decision trees learning process to optimize the learning procedure. Here we can see the flowchart of a random forest model. We have the feeding data set. We apply bootstrapping, and we have different samples with different data points and different variables, and the decision trees are solved, and finally we have the average of the estimations produced by the optimization of the decision trees included in this analysis. In this transparency, we can see one individual regression tree, which consisted of a corrected flowchart, where there was a unique starting node from which two edges branches started and at children nodes that come from a parental node. A condition of satisfaction has been settled for each node, and if this goal was not achieved, the process moved on to a new hub and new children. By working in that manner, the random forest regression algorithm presents an important advantage. It avoids overfitting of the final model. Both machine learning models was achieved by using libraries of scikit-learn and the Python programming language. Now, the statistical criteria for model evaluation used were the root mean square error, the coefficient of determination, the bias, the relative sum of square errors, and high model performance is indicated by low root mean square error, coefficient of bias, and the relative sum of square errors, coupled with the coefficient of determination values. And now the results. In table 2, we can see the optimal hyperparameters values for both modeling approaches, which were assessed using the grid search methodology in the red boxes. And in table 3, we can see the evaluation criteria for both modeling approaches for the feeding and the test data sets. As we can see here in the table, both the models held similar, more or less, outcomes. However, the GPR model provides the most accurate and reliable results for both the feeding and the testing datasets. In this transparency, we can see the GPR model performance associated by its uncertainty. SE-by-SE regression technique, this model offering a probabilistic approach to inference, enabling the prediction of not just the expected value of a target variable, but also the uncertainty associated with that prediction. And finally, the conclusions derived from this study can be summarized into the following points. The model's evaluation criteria showed that the Gaussian process regression model exhibited better performance. The random forest of regression modeling approach gave more or less similar results to those derived from the GPR. Thus, both machine learning approaches could be considered as reliable alternatives to the nonlinear modeling. Gaussian process regression, offering a probabilistic prediction with a mean invariance, provides a natural measure of uncertainty in the predictions. This evaluation is particularly useful in forestry, where risk assessment is essential for the effective implementation of sustainable forest management. Finally, the flexible structure of random forest algorithm helps prevent the serious issue of overfitting and enables the system to handle real-world data, which often includes challenges such as high variance, outliers, and missing values. However, it's important to note that the further are predicted values from the range of the fitting data, the less reliable that prediction will be. At that point, I would like to thank you very, very much for your attention. Thank you.
Thank you very much. Thank you for keeping to the time. Do we have any questions? Let me ask quickly, Professor Diamantopoulou, do you see this method being used in the actual forestry sector easily? Do you have a path to real-world usage of this method?
Yes, this is a problem. In order to use these models, someone has to have skills in computing. So it is not so easily applied in practice forestry. But we are here to show the way, and then all the others are a matter of education, policy. I don't know what to say more.
Okay. Thank you very much.
Thank you.
We now move on to the next presentation, which is in real life by Nikos Polymenakos on a novel low-cost system for Xylella fastidiosa early detection. Mr. Polymenakos, please come to the podium.
Good morning. Can you hear me? Let me check. Okay. Good morning, everyone. Let me introduce myself. I'm Nikos Polymenakos from Ionian University, Department of Informatics. I work in the CMOD lab, Computation Modeling Lab in the same university. Today, I will present you a novel low-cost system for Xylella fastidiosa early detection using electronical conductivity probes. Starting with the introduction, Xylella, for everyone who maybe not know, is a devastating pathogen affecting all kind of cultivation back from the 80s. But from 2013, the oil cultivation in southern Italy has a crucial problem. Monitoring and early detection are crucial to minimize economic losses as soon as possible. Next, for the introduction, the proposed system uses electrical conductivity that we present you later in order to detect a pathogen presence based on the OQDS. OQDS is an olive decline, olive quickly decline symptom, which is basically the quick drying of the whole tree. Of course, we have to be energy autonomous because we are, something is not working properly. Okay. Okay, we have a technical problem. No words. Okay. Okay. If I'll change the slide, it's better? No.
It's flashing on and off. Okay. No?
Even if I change it's not working fine.
Okay.
Okay,
Carry
now
on.
it's
No?
unlucky again.
Our technical team is running off their feet to try and solve it. Okay. Can we carry on?
Yes, now I think it's stable.
All right, go on.
Okay, the last box says that, and again. Okay. No words.
If you know your presentation, just carry on and they'll sort it
Yes,
out.
I know, but I want to share also the slides. Okay, let me try at least.
Try.
The last box says that we need energy autonomous because we are on an estate, on an olive orchard, so we have to be energy autonomous, and of course real-time monitoring are crucial features for our system. Our motivation was of course the importance of olive cultivation in Mediterranean countries, as you all know, in terms of finance, culture, and of course history. So there is a big need for effective infrastructure to monitor research, early warning, and manage at last Xylella fastidiosa. But our primary also motivation was our location, geographic location, which is Corfu, is the first island next to the big problem, which is currently centered in southern Italy. Our objectives was very clear. First, design, next, develop, and lastly, create a pilot installation in the olive grove. Of course, to create a proof of concept of low-cost system. Then, we had to create almost real-time data collection via GSM network because, as I said before, we are on the field. With all this, we can build an early warning system for Xylella fastidiosa detection. All these objectives aims this, that to create an innovative solution for protecting a historic olive orchard, not only for Italy, but also for all of the Mediterranean countries. Our methodology, based on this, that all the trees has electrical resistance, as you may know. But the electrical resistance is inversely related with electrical conductivity, which our probes calculates on the tree. Next, we have to monitor the stem water as a health indicator. The stem water is the water that is inside the tree trunks. The first calibration that we made was okay for now. We thought that we can set the 0% if we have the probes in the air, and we have 100% if we install the probes inside some kind of water. And of course, as I said before, we create a feature for data transmission, not only for sending the data back to us, to our server, to analyze further the data, but we couldn't bring back the whole system in our location for dangerous reasons. It was very dangerous if we spread the Xylella in our location. Some of the components, an example, we started using, as you see on the left picture, a very small microcomputer, which is very powerful for our work. It's a Raspberry Pi 3. Next, you can see this purple one, which calculates the voltages of the probes in real time. And next, we attach some extra electronics. This in the left is a real-time clock to ensure that even if we lose connection in the future, we can ensure that we have timestamp next to our measurements. And of course, a USB modem that we installed to include the SIM of the GSM network. Next, of course, we have all these energy solutions, solar panel, battery, and some relays for energy optimization because, as I said before, we are in the field and there are lots of problems. Here you can see a picture of the first electric components inside the box. Some things about the location that we chose. The location was in Ostuni. It's in southern Italy, and there was multiple olive trees that already had Xylella, and lots of them already cut it down. We picked an olive tree that was already infected by Xylella fastidiosa, and we installed, like this, our probes to 2 different branches in order to have differences in the measurements. Here you can see our results. We have 3 different periods, but in the same year. We started in July that we installed the system, and as you can see, the red one is the branch 1 and the blue one is the branch 2. As you can see, in the first days, in the first month, we have very similar stem water percentages. That is okay for us. Next, in August, we have a slight difference with the blue one that was lower in compared to the red one. And of course, in November, we have a very significant variation, more than 9%, which refers to Xylella fastidiosa. After this experiment, I have to say that the tree was cut down nearly in February because it's totally destroyed by this infestation. In conclusion, today I presented you a low-cost electronic conductivity probe system which shows promise for early detection of the infestation. Significant differences in stem water, as we saw earlier in the previous slide. We can see signs of the infection. The 9% decrease in branch 2 aligns with known symptoms of Xylella fastidiosa, which I told you before is the quick drying. And of course, real-time collection was very helpful for us and also for the cultivators because they must know as soon as possible these results. Of course, we can use the system also for future improvement in terms of sensitivity, expand field trials if we want to build more and more systems to create a network of these local systems, and of course to explore more applications. You will see another application in the next session by my colleague Nikolaos Augustis, and you will see how we can use these stem water measurements in order to calculate and simulate the fire spreading. It's a very different application from this one. Some references, that was very important to me, and thank you for your attention.
Thank you very much, and for keeping to the type of the time lost. Do we have any questions? One quick question. Yes?
How early can you detect the effect of the lower conductivity?
Sorry, can you repeat?
How
again?
early can you detect the effect of the conductivity decrease?
Yes, we can detect the decrease.
How early?
How much early? It depends on how the branch goes down. How early? I think in real time, because if we we measure in real time the electrical conductivity. So we send the data every, I think, every day in exact 12 o'clock. So every day we can see the variations of this electrical conductivity, which refers to stemmed water inside the trunk.
I mean, the effect is visible before being observable by the farmer.
Visible, you mean on the tree? No, I think it's earlier. I think it's earlier. Yes.
Thank you very much. Let's move on now. We have a...
I have another question.
Okay. No.
We have time for a quick question.
Go on, a quick question.
First of all, congratulations to these young guys. They are trying to solve the most important problem in Xylella, which is a billion problem. Those who are from Italy, and if they solve it from Italy, they will save Spain, they will save Greece, they will save everything. My sincere congratulations to these young guys. Second, I rephrase the question, the previous ones. You can very easily set up a warning percentage difference, I don't know, 8%. So this is the time that you will start the symptoms. So try to find out what is a critical threshold value for the appearance, not the visible, before the visible. The problem is you can detect it. You cannot do much. But at least if you detect it, you can cut off the branch and burn it. That's a very simple solution. My really sincere congratulations to all your team. Thank you.
Yes, and that was our thought. If we know in real time the stem water percentage, we can, yes, we can be more.
All right, thank you very much.
Thank you.
Our next speaker is speaking physically and present here. Evangelos Alvanitopoulos is going to talk about an agent-based simulation model for red palm weevil dispersion in Corfu. Please go ahead.
Thank you very much. Good morning, everyone. I'm Alvanitopoulos Evangelos, PhD candidate from Ionian University and also member of Simon Lab, as you saw earlier. In this presentation, we will see about an agent-based simulation model from red palm weevil population dispersion in Corfu Island, located in Greece. The red palm weevil is a highly destructive invasive species pest that primarily affects palm trees. Our main objective is to create and build a simulation about the population spread of the weevil in Corfu Island, Greece, over a 4-year period. Additionally, we aim to evaluate factors such as palm tree density and the distribution of the trees. In the end, of course, our main goal is to create and build a decision-making tool for the red palm weevil. The red palm weevil is a highly destructive, as I told earlier, pest that has spread globally, and it's causing major ecological and economic damage to the regions that has invaded. As you can see in the picture, you can see on the top over here a palm tree located in Corfu Island. Top right corner is the tree before the infestation, and this is after the infestation, the tree after the infestation. As you can see, the trees have fallen and have the looks of an open umbrella. It's a common symptom from the infestation of the red palm weevil. Okay, now the red palm weevil, it causes the major damage when it is on its larval state. Because the larval, it feeds on the young leaves of the top of the tree and also the internal tissues of the tree. Of course, the infestation, the tree is dead and cannot be saved. One of the main challenges of the infestation of the weevil is to early detect it. It's very difficult because the weevil is inside the tree and cannot be seen by the naked eye. And when finally the symptoms are began to show, as you saw earlier, the open umbrella, it's already very late and the tree cannot be saved. Now, for the simulation, we use to simulate the movement of the weevil ecological modeling and geographical data for the simulation of the Corfu Island. The simulation starts by mapping the initial position of the trees and also the starting point of the infestation. In our case, we already know when and where the infestation began. And also for the movement of the weevil, we use random walk algorithm. Now, according to our data, after analyzing it, we did some assumptions. For instance, the first one is each palm tree can be infected only once. The second is when a weevil flies in close proximity, in a certain radius near the tree, the palm tree attracts the weevil. And of course, for the life cycle, we include egg production, time to adulthood, and death. Now, in order to implement those assumptions, we have some control variables. First is the palm density, is how many palms are in a certain area. In our simulation, we use patches of palm trees. The next one is spatial distribution, the distance between these patches. Next is the drift factor, as I told earlier, is the attraction of the red palm weevil. And next, in the end, is the fly speed of the weevil that dictates how quickly the weevil can transfer in a simulation. For the ground truth, we conducted many research about the palm weevils, and we gathered additional insights from multiple municipalities, gardeners from Corfu Island, Ionian Islands, and other regions in Greece, in order to get all the details and calibrate our simulation. Our findings indicate that in Corfu Island, in a span of 4 years' time, the weevil has spread all over the island. Now, for the results, as you can see in the images. First, the simulation confirms that in areas with closely clustered, with many patches of palm trees, we have experienced a rapid infestation. The isolated trees are safer for now, and the result is, in 4-year period, the red palm weevil have spread all over the island. As you can see in the images, the first one is from the first year, second, third, and fourth. As I told earlier, you can see in the second year more clearly that the starting point of the infestation was in Corfu City, Corfu, the main port of the island, and in the south of the island, which is located another big port. In conclusion, we saw that the tree density and distribution clearly affects the infestation dynamics. Densely populated palm trees, these patches of trees, are more vigilant for monitoring and pest control methods. And, of course, we saw the importance of early detection and rapid intervention in order to prevent the widespread of the weevil across Corfu and other regions, of course. The last one is that all the insights, all the data, all the information, all the knowledge gathered and gained from the simulation can be used for creating better or new pest management methods, strategies, and apply similar methods and models to other regions and other, of course, invasive species. And thank you very much for your time.
Thank you very much. Thank you for being so quick and efficient. Do we have any questions? Yes.
Would you agree that the spread of red palm weevil is based on commercial importations to various areas?
Yes.
Only commercial?
Yes, of course.
And not climate and
No. Yes.
wind drifts?
In our case, Corfu Island, the palm trees were imported for the Olympic Games and hotels, villas, because Corfu Island is a highly tourist island. And in one of these palm trees imported had the red weevil. This is how it spread on Corfu. And in other regions, according to our study and research, it's only for commercial reasons, yes.
Thank you.
Any other questions? All right. Thank you very much.
Thank you.
Our next speaker is Mr. Pedro Gonçalves. I hope I've not destroyed the name. He will present on gamification of the agritourism industry to maximize efficiency. Please, Mr. Gonçalves.
Thank you. My name is Pedro Gonçalves, and I came to present a running project. Most rural areas in Europe are experiencing a process of depopulation. There is a huge loss of young population because of the lack of economic activities that give them income. The abandoned houses and farms, they are very attractive to urban tourists, and tourism-related activities, they create local income, and they retain some of the population due to the workforce they employ. They are, however, limited in terms of offering some leisure activities to the city population, and because they have some problems capturing their interest. There is a huge complementarity between tourism and agriculture activities, and they give mutual gains to the both activities. The tourism companies, they can use fresh and add value agricultural products in catering, and agriculture tasks can be entertainment for hotel guests. The game project is funded by the Recovery and Resilience Plan within the Revitalization in Rural Areas Agenda. The project has two main objectives: to promote the revitalization of social capital of rural areas, and to promote the creation of more companies in agri-food sector and related activities. We defined some 4 operational objectives, like the digitalization of agriculture by the using of smart technologies and sensing the livestock and the farm activities. A second was the exploitation of agritourism by using a digital platform that allows to enhance the visit farmers' experience. To use a platform as a gamification tool that gamifies the participation of tourism in the agricultural activities and offering a kind of participation prizes. And the fourth was to create a knowledge sharing platform that for the farmers to hold training sessions within a vocational school. So the main idea behind the game project was to create a mutual gains between the tourism operators and the farmers. So when the tourism visits the rural areas, he participates in farm activities, and he can buy some farmer local products. And when he stays within a hotel, he receives credits for his presence, and he increases the period of permanence. So the idea behind it is to have a central platform that keeps the system operating, that can recognize the tourism presence within the farm activities, and verifies the presence within the hotel. So the gamifying process confirms the presence using IoT technologies like NFC, like BLE, by QR codes, for instance. So it confirms the presence of the tourism within the hotel. It confirms the presence, the participation of the tourists in the farm activities. In the platform advertises the hotel products, the promotions. It advertises the local products and keeps streaming the pilot information. The pilots, once the tourist gets home, he keeps receiving the pilot streamed information. I will talk about it later. It keeps advertising hotel offers. It keeps advertising farm products. So it continues the experience and the call for receiving the tourists in that region in the future. The pilots are referred. They are 4, one in the north of Portugal. That's a village nearby Rio Douro. And the Baião pilot will stream information about ship monitoring. It will stream information about monitoring the growth of blueberries, the kiwis, and other fruits that they are grown there. And they will use audio guides to guide the tourists and improve their experience within routes in the region. We are creating a second pilot at Mogadouro in the north of Portugal, where they are streaming information about the local donkeys and the goats, monitoring the growth of fruit, of vegetables, and some fruits there, and the humidity and the temperature behind those plants. And we'll have their audio guides within the routes of the region as well. The fourth at the Guarda, it is in the interior, very near Spain. That's a quite dry and mountain region. We will stream from there information about monitoring of gemalist cattle. That's a kind of cows that exist in the region. We will monitor the sheep. We monitoring the cheese production from the sheep that exist there. We'll monitor as well some fruits and vegetables with the humidity, the temperature, and we will have audio guides within the routes in the region. Finally, Coimbra pilot, that's very in the center of the country. We will monitor the growth of fruit and vegetable crops that exist in the school, and we will keep monitoring the existing cattle. We will have as well some guides and enable with audio within the farm. In the middle of the gaming scheme, we will have an Android app. We always have our handy phone, and our handy phone is enabled with a lot of sensors, so it will recognize the presence of the users within the hotel, within the farm activities, and the app will be personalized for each user, and will allow the verifying of our application. We will enable us to keep receiving notifications about the offers at the hotel, offers at the farming, and we will allow the user to use the prices to get the offers both from the hotel and from the farmers. So I think that's the presentation.
Thank you very much. Do we have any questions? I have a question, which is, can you explain a bit more about the gamification aspect here? Is there a kind of process that it stimulates or encourages the user to engage?
Yes, it is. Our plan is to have a mutual gain both for the hotel owner and for the farmer. If we ask the hotel for receiving local products, he will do it by a small period and he'll forget it. So the base plan is to have mutual gains both from the tourism operator and for the farmer. So the producer, the farmer, will feed their local products, the cheese from Guarda, the blueberries from Baião, and we will sell it to the hotel, and both for the tourists. And their activities, when they are cropping the blueberries, when they are producing the cheese, when they are visiting the flock, they will be entertained and will increase their period of presence within the hotel. So the base plan is to have mutual gains, that both of the operators gain with the relation with the other operators, and improve the gains for both of them and create income for the rural areas.
Thank you very much. We move on now. We are, Ms. Lulio has not connected up, so we move on directly to Mr. Athanasios Yertsis on the evaluation of flight directions and other canopy coverage characteristics from aerial spraying. This is a face-to-face, a real-life presentation. Thank you very much.
Thank you too. Thank you to all of you in advance for your attention. I'm going to present today something that I believe it is the future and the most immediately and most friendly and most efficient technology for farmers, the drones, spraying drones. So this study, I presented on behalf of my Pandelis Kostadaras. That was part of his bachelor thesis. And we will evaluate flight directions on a spraying drone. There's going to be a 2.5 minutes video at the end of the show. I believe that that video will tell you more than what I'm telling you by the text. So, linear high-density system plantations happen and they dominate everywhere. Of course, vineyard was the oldest one. Now olive production systems are becoming linear systems. And also many, if not almost all of the fruits, the main fruits like apple, pears, apricots, etc. And they have significant advantages. That's the reason they become dominating in the agricultural sector. Now let's go to the drones. There are many drones. I will specifically concentrate and focus on what we usually call in Europe UAS, unmanned aerial systems or unmanned aerial vehicles. Last summer I met with an American and they are using a much better acronym, remotely piloted aerial application system, because these drones are not only for spraying. They also have many advantages. Again, the video will demonstrate, you will be evidence the advantages of this. There is one characteristic thing about these technologies. What I'm telling you right now about spraying drones, it's valid only for the next year. Next generation, it will become much better and so on. So what were the main objectives? To compare flight direction parallel to the linear systems and vertical, perpendicular, in order to see which way, with the same amount of spraying solution, we can achieve higher % coverage. For this, we used two different drones, an older generation and a younger one, different technical characteristics, but we use the same spraying settings. You will see what are the settings. So, in the next slide, you will see the plot outline. We placed what we call water-sensitive papers to measure the % coverage. This high-density olive grove consists of 3 planting densities. Actually, I think I will better go to this slide so you can see what I mean. So this is the olive grove. It's only 3.2 hectares, but we planted here about 13 years ago 364 trees. And the same area in a traditional olive grove everywhere, usually they plant between 250 and 300 trees. And our planting densities varied from 500 trees, this part, the first line, these 4 lines, 500 trees, 1,000 trees, 1,670 trees. What's the big advantage of this olive grove and this type of olive groves? It can be harvested manually. Sorry, not manually. It could have been a great problem if we have to harvest it manually. It is harvested mechanically. So we have 2 flight directions, and you can see the console. These drones are totally programmable. You can set everything, the height, the speed, how much they will spray, which direction they will fly, and other things. And that was the first model we used, a 16-liter model. And we used 2 open access software. One is an application in your mobile phone. You can download it. That SnapScan model estimates only % coverage. Whereas the Deposit Scan, which is software developed by USDA, United States Department of Agriculture, that software gives you many more information. And we use JUMP. I love JUMP as compared to SPSS for statistical analysis. Again, I need to make a note here that only partial data are presented here. We have collected more, and we are collecting more data because this is a continuous study. These little yellow papers, we put them in the tree in various positions, and after they spray, we take them, we scan them, and we can calculate how many drops are in. These water-sensitive papers represent or simulate the leaf. Let's go directly to the results. For the first flight, what we noticed, and here I'm giving you results from both software. You will notice that the numbers are different between the 2 models. It doesn't matter. The critical thing is here to observe that the perpendicular or vertical flight direction was significantly higher, significantly statistically higher than the parallel. The same thing we have seen it by scanning with the snap card. In a previous study, which is actually presented in one of the last HAICTA readings, and it is part of a chapter in a book, I have done a complete regression analysis, and there is a totally linear relationship. So if you want to use this model, which is much easier, it takes less time, and you want to convert it to this, which is more accurate, and only for percentage coverage, you can use the regression model with a 96% probability. Now, then I wanted to test the hypothesis, okay, what happens among the 3 planting densities? You recall they were quite different in terms of trees and density of the canopy. We didn't see any significant difference. We didn't even see significant difference on the position on each tree, the upper, the middle, and the low. What does it mean practically? I'm a farmer. I'm talking like a farmer right now. I want to see if the drone covers equally well the upper part of the tree, the middle part, or the low part. So that has proven. Did density influence the spraying? No. So these are also very important results for practical uses, for efficiency. These are some, now we used another drone from another company which has a higher tank capacity, 30 liters. These are some of the settings. And this is the drone I was talking about. Again, 2 flights with this one. The same results, perpendicular and parallel. We have seen a slight difference in planting density with the first flight, but not differences in upper, low, and middle position. The second flight, the same tendency of results, statistically significant, the vertical. Again, we have seen a little difference in planting density, but no differences on the profile of the tree. That's a gentleman who helped me from the company. And recommendations, practical conclusions and recommendations, we suggest for this type of systems, for high-density olives, that the vertical flight is more important. You don't worry about the tree profile on planting densities. I guess we were going to try it in a traditionally spaced system. So I need to make a warning here. These results are valid only for the system of olives and for the settings applied. We are continuing this study with variable settings. So I put an asterisk here, like vineyards, apple, pears, etc. We are doing additional studies continuously. This is part of our teaching and research in Perutis College. I will tell you something unofficially, that last week I analyzed the data from the vineyard. We have a vineyard on this. So, since I have only 1 minute, please enjoy the video. The video is about 2 minutes. And I can talk a little bit during the video. Now, the drone, after it takes off, orients itself, and it goes to where we ask it to start spraying. So this is going to spray this area. It goes up and down. This is the parallel direction, and you can see it has 2 centrifugal nozzles, while the other drone, the previous drone, had 4 conventional nozzles. But it doesn't matter because the amount of water is equal, but it's not the same with the size of the droplets. The centrifugal makes much finer droplets, which is even a little bit better than the traditional nozzles. In this video, you will see also the vertical one in a while. And you can see that if we have to spray this area with ground systems, I can give 3 students of mine a backpack 15-liter sprayer, and that might take them about 3 students. I time them. It will take them about 30 minutes for 3 students to spray it. We did it in 4 minutes and 36 seconds, and with much less spraying solution. Now you'll see the vertical one. Again, the drone goes. We can set up when it's going to start, and when it's done, it automatically returns to home. Now, what if we spray larger areas and it runs out of battery or it runs out of spraying solution? No problem. It will return home. We will refill it, either the battery or the tank, and it will continue from where it stopped. They are becoming very smart. The problem remains the user, us. So, thank you very much. I took you 1.5 more minutes than the 10 minutes, and I will enjoy any questions, either during this time or I'll be glad to have a discussion aftermath. Thanks again.
Thank you very much. Do we have any questions? Yes, please.
What was the amount of the sprayed fluid?
It was 6 liters per strema, 60 liters per hectare.
Yeah. It is quite restricted.
Sorry?
Restricted. It is quite restricted for this type of
What
commercial
do,
use.
what do you mean restricted? I'm sorry.
I mean, we need a drone with more liters of spread formulation.
Why you say that?
Because
Well,
the
just to help me understand it.
are very big, not just 2 or 3 hectares.
Oh, okay, I got your point. Yes, the tank capacity is small. It doesn't matter. Think of this. All I have to do, now the next drone we will try will be 50 liters in the next couple of weeks. Okay, it runs out of liquid, of solution. It will come back. All I have to do is refill it and resend it. It's the limitation here. It's not the tank capacity as much as is the battery. But I have 3 batteries, 4 batteries, fast charging batteries. Believe me, that's not a limitation. Now I understood your question. It's not a limitation. And what I'm saying right now, it's not going to be valid next year. Next year, if you ask me the same question, I will tell you that, wow, we have a 50, 100 liters drone. The battery lasts 20 minutes, and it's charging in 10 minutes. It's unbelievable how fast this technology is moving. I hope I answered your question.
Thank you very much.
Thank you too.
Okay, our next speaker is Mr. Efstratios Sentas, who will give a real-life presentation on the spatiotemporal patterns of olive fly movements.
Okay. Hello from me. My name is Stratis Sentas. I'm from the Prek Farm Laboratory from the Geography Department of the University of the Aegean. And I'm going to show you our research about the spatiotemporal patterns of olive fly movements, the role of variety, temperature, and altitude in 5 olive oil production areas in Greece. Okay. A little about the insect. Okay, you know maybe the olive fly. It's this one up here. Oh, okay, up here. The damage caused by the female one because it lays her eggs inside the olive, and through the biological cycle we have the new insect. Every year, olive fly causes damage of millions of euros because we have quantitative and qualitative damage. Also, millions of euros are spent to control it. In Greece, we have the national program to control the olive fly, which costs also millions of euros. And we have two parts of it, the traps and the sprayings. Okay, we know a lot about the biology of the insect, but how about the ecology of the landscape of the insect? What does it mean for the olive fly? What is the effect of the landscape on the dynamics of insect populations, biotic and abiotic factors, altitude, microclimate, food availability, etc.? What is the effect of landscape on the infestation or not of the olives, the condition and quality of the olives? And the spatiotemporal population dynamics, for example, outbreaks, seasonal movements, and or population from lowland to mountainous areas, and vice versa. For this reason, we developed an integrated GIS system. Consists of 3 levels. The first one is the user level. We have the Android app and the computer application. The second one is the WebGIS level, where we have the management and monitoring application. And the third one is the geospatial database, where all the data from the National Controls program are stored, and it's available in real time. Here is the Android app. We're using it for the traps, the Macphail traps, like this one, the glass one. Every man who does the changes of the traps has this app installed on the phone. It opens it, it logs in, it selects the area that he wants, or she wants, and after that, you can see the red points, it's the traps of the area, and the blue one, it's the user locations. When the user location is within 20 meters, he can check this button that says location check, and the app opens, and they can insert the population numbers. If the user location is above 20 meters, then he will get a message that says get closer to a trap. This means that we have better measurements. We have measurements that are correct. Also, we have available all these populations in real time in our WebGIS application. Our study areas now. We have Chalkidiki, Lesbos, Samos, Lasithii, and Chania. Those areas are completely different from each other. Okay, not completely, but different from each other. There are continuous and discontinuous olive groves. There are also different altitude, different climate conditions, and cultivated varieties, the main cultivated varieties, basically. What data we have now? We have the fruit flies per trap from June 1st to October 31st for the years 2022 and 2023. We have the temperatures per hour from the climate, from a weather station near each area. And our methodology was to calculate the fruit flies per trap and per month for each region, the fruit flies per 10 days and per trap for each region, the fruit flies per elevation category. We chose those categories because are the zones that the olive is cultivated in our areas. The total hours per 10 days when temperature is over 32, 35, and 37 degrees Celsius, because this, according to the literature, it's the limits than our insect is weaker or killed. And we calculate the correlations of fruit flies per 10 days with elevation categories and region. Our results now, the total numbers of olive flies per 10 days and regions. We can see that in Crete, Chania, and Lassithi, we have higher numbers in both years, but the pattern is almost the same. In 2033, we have lower numbers instead of 2022. This is maybe because of other external factors, such as the cultivation techniques, irrigation maybe, weather conditions, and I don't know, anything else. Here is our values distribution for the selected regions. We can see that the higher values are from Lassithi, okay, for almost every month. Also, we have a lot of extreme values in Chania, which means we have very high populations in the individual cases. And as you can see, in most cases, in September and October, we have the highest values, but in Lassithi, we have the highest values on July and August. Our Z-scores now. In Lassithi, we have the higher Z-scores, which means that we had a large deviations of the values for the mean. Also, the areas of Lesbos, Samos, and Chalkidiki have lower Z values in almost every case, which means that it's near zero and that the measurements are closer to the mean. Here is the impact of temperature thresholds on olive fruit fly populations. You can see with the black line the olive fruit flies, and with the colored ones the temperature thresholds. We can see that in almost every case when we have high temperature, for example over 35 and 37, we have lower numbers of olive fruit flies. We can see that especially in 2023, where we have in general higher temperatures and lower populations. Here is another example. We used data from the previous years. We have the north and south deviation differences. As you can see, in the north part of the Samos, there are more insects than in the south one. And because in the north part, we have lower temperatures during summer than in the south part. This is mainly because of the mountains that we have in the center of the island. And last, we made an ANOVA with the monthly olive fly numbers with elevation categories and region. We saw that all months saw statistical significant differences between means of the groups. The result indicates that the presence of the insect varies significantly by altitude and region. Also, as you can see, in the last months, August, September, or October, for each case, we have higher values. Also, in June 2023 and June 2000 for the region, and June 2022 and 2023 for the elevation categories, we have a significant p-value, but the f-value is much lower, indicating a weaker effect compared to the other months. And now our conclusions. There are special patterns of location-related differences. In some areas, the climatic conditions favor very high populations. There are differences between regions depend more on the relative position than the other factors. The elevation and therefore the relief of the region in each area is important, and the variation for each point trap can be very strong and vary especially over the years. And that's it. Thank you so much.
Thank you very much. Do we have any questions? I have a question for you. Am I to interpret this to mean that the high temperatures we had in Greece this summer, for example, would reduce the level of
It
fly?
made it almost zero.
Right.
We have the lowest populations than I studied the olive fly like for 6 or 7 years. I've never seen such a low population than this year.
So this is interesting because in a lot of areas of climate breakdown, we're seeing an increase in infestations from one this pest or another, while here's an example where it goes the other way.
Well, the other way. Yeah, the climate change is is different.
Very interesting.
We will see. Thanks.
Thank you very much. We now have Miss Sofia Lulio on the line, who will give a remote presentation on the assessment of autonomous mower effects on Phyla nodiflora and pollinator presence in urban lawns.
Yes, good morning. I'm going to share my screen. Do you see it?
Not yet. Please try again.
Now?
I'm waiting. It's not coming through so far.
Do you see it now?
No, I'm not sure. Technical team, can you tell us what's going on? They're pointing a finger at me. Try again, please. Is this a problem at our end or at her end? Okay. Try again? No, wait. Wait. Sorry, I'm interpreting hand signals. No, something's changed here. Okay, so we're going to do our next in real life presentation and then come back to Miss Sofia Lulio afterwards while they sort out the technical issues. Could I invite Minas Ververis to come and give a talk on the development of rust disease prediction models with the use of satellite-derived vegetation indices from wheat and maize parcels in Kenya and Uganda. This is a remote presentation. Yep.
Θα παρουσιάσω εγώ.
Ah, there you are. We can see you. Go ahead.
Should I start?
Yep, please start. Go ahead.
Hello to everybody. My name is Minas Ververis. I hope that you can hear well. I'm an agronomist working crops company. My protection, I'm in crop protection, plant protection, and AgroOps, the company in which I'm working, provides digital solutions for agriculture. I will present you our work on development of Rust. Just give me a second because I have an issue with PowerPoint. I will present you our work on the development of Rust disease prediction models with the use of satellite-derived vegetation indices from wheat and maize parcels in Kenya and Uganda. This work has been done in a collaboration from AgroOps in collaboration with Sapienza University of Rome in the framework of the AfriForecast project that received funding from the EU Africa Explorers as part of the European Space Agency EU Africa Initiative. Starting with the importance of Rust disease in Africa, these pathogens pose a threat to food security with potential yield losses leading often to food shortages and increased malnutrition rates. Yield losses have been recorded up to 80% during severe outbreaks, with Kenya and Uganda specifically, which are main wheat-producing countries, facing many challenges from these outbreaks, like the UG99 strain epidemic, which was the most devastating one that Africa has faced. So there's an increased need for timely interventions to enhance the efficiency of plant protection in these areas. We should have in mind that resources are limited in some remote rural areas of Kenya and Uganda, so the farmers do not have access to a wide amount of fungicides or reliable equipment for spraying. There have been some advancements in detection over the last years. Non-invasive techniques have emerged for Rust detection using various sensors, which gradually presented all the better results. Predictive models have been employed using spectral indices that can help detect stress patterns for several plant diseases, not only Rust. These advances would facilitate timely interventions in order to the crop productivity. So it's very important to implement the strategies to the farming plan in order to strengthen the resilience of African farming communities. Now, the objective of the project objective was to establish a continuous crop monitoring system in order to detect Rust outbreaks in wheat and maize. This was our first. We wanted to do this by a combination of satellite indices. We would calculate the disease index, which provides the percentage of infected area on the crop based on hyperspectral images from the Prisma satellite. In three different infection stages, the early, the mid, and the late infection stages. In order to cross-check the results, we would calculate the red edge disease stress index, the red C index, using available satellite images on the same dates. The steps for this process was to co-registrate Prisma and Sentinel-2 images, extract Prisma bands, calculate the indices, and make the comparisons. On the study areas, studies have been carried out in Narok County of Kenya and in Baku district of Uganda. In situ studies included 90 parcels of wheat, 40 in Uganda, 50 in Kenya, and 50 parcels of maize, all in Kenya. Rust scoring was done based on the Cobb scale methodology, an already established methodology which is depicted on the picture on the bottom. 3 to 5 spots being measured within the parcel, and in each spot we measured 30 leaves and approximately 15 stems. This process was carried out from third node stage up to the grain development stage. Now for the satellite data, here we had some significant challenges. These wheat and maize in Kenya and Uganda are rain-fed crops, so the growing season of these crops coincided with the rainy season of these tropical areas. So this led to a cloud cover of approximately 6 months, continuous cloud cover, with a few dates as exceptions. This hindered the image acquisition, and in order to overcome this, we tried two different approaches. We found some Planet and Landsat 8 images close to the field campaigns. On the Planet images, we tried a similar methodology. We calculated the disease index in 3 different stages, or to calculate the disease index in 3 different stages, and the red sheet to validate the algorithm. On the Landsat 8 images, we tried a whole new approach. We calculated 35 new, spectral indices covering a wide range of biophysical parameters of the crops in order to develop new detection models. On the Planet approach, there were cloud-free images, but not enough for a temporal analysis on the different infection stages. In this process, correlation was sought between the real rust severity and the index values. And in order to accomplish this, we need to calculate the average infection severity from each parcel and compare it with the calculated disease index values. Analysis was only possible in the early and late infection stages due to the lack of images in the mid-infection stages. And the correlation was made on the assumption that the lower rust severity was related to earlier infection stages and the higher to later infection stages. Results seem to be promising, with general behavioral data inconsistent, especially in the late disease indices. But I do not have more results on this because the analysis hasn't been complete yet in this part. Landsat approach, as said earlier, we calculated for each parcel 35 spectral indices, and the data were separated into different data sets. The wheat data set included data from wheat parcels in Kenya, the maize from maize parcels in Kenya. The wheat and maize was a combination of the two, and the top included all parcels from Kenya and Uganda, no matter the crop. On each data set analysis was made separately. It was treated as a separate treatment. First, moved on. Variance inflation factor was conducted in order to measure multicollinearity, using 5 as a threshold. Multicollinear values were removed as well from the dataset, and feature importance was assessed using incremental R-square. On the regression model development, polynomial terms were generated with a degree of 3. Data were transformed after scaling to include original features squared and cubed terms and interaction terms. Regression was performed using ordinary least squares, and we retained only the statistically significant predictors. Now on the results, the Landsat, the wheat parcels in Kenya, from wheat parcels in Kenya, we managed to develop a model with moderate predictive accuracy, which was susceptible to overfitting, as you can see in the table to the right, with an R-square of 0.59 and an adjusted R-square very low of 0.16. From the maize parcels, we developed the worst of all of our models with very poor accuracy and overall performance. Both R-square and adjusted R-square were very low. From the combination of the previous two datasets, we achieved better accuracy, but the model was still susceptible to overfitting, having a smaller adjusted R-square of 0.34. The R-square was much better at 0.75. And then finally, in the total dataset, which included everything, we saw a significant improvement in both accuracy and overall performance of the model, having an R-square of 0.75 and an adjusted R-square of 0.65. Thus, because this model was the best in every aspect, we decided to keep only this one. And on this model, we saw that the most important features was the wide dynamic range vegetation index, the blue wide dynamic range vegetation index, the visible atmospherically resistant index in green bands, and the green atmospherically resistant index. Now the wide and the blue wide dynamic range vegetation indices are very sensitive to slight variations in vegetation, which is something reasonable because near reflectance decreases as rust progresses in the crop. The vari green index is sensitive to changes in chlorophyll, which also is expected because as rust pastures grow, the leaves start to turn yellow. And to carry the green atmospherically resistant index is sensitive as well to changes in the green and near infrared reflectance. So we can see that these results are reasonable, and helped to develop a more robust model. The gradual improvements that we saw between the models could be attributed to the data quantity because the Witt and Mays dataset and the total dataset included many more data for model training. But it could also be attributed to the variations in crop characteristics. As you saw in the previous slide, the Witt and Mays combination presented much better results in R square than the previous two datasets. This is because of the differences of Witt and Mays of crops, but we also had differences between crops in Uganda. We know that the growing seasons were different. In Uganda, it was much smaller, and this could affect the rust disease. And we also noticed that the characteristics, the size of the crops were smaller. On the final model, we achieved an adequate accuracy, but we believe that there is still a lot of room for improvement. On the future steps, we would like to apply this methodology in areas with less cloud cover, which was the main issue here, in order to acquire more and improve the quantity and quality of data, and thus enhancing the accuracy of the model. We would also like to include some additional indices after a detailed scientific literature review to detect some sensitive to rust-related stress indices and include them in order to improve the model sensitivity. What we would like to work on in the future is to include weather parameters into the model in order to develop a dynamic climate-aware model better suited for predicting rust outbreaks. Most of the plant diseases, specifically those caused by fungi, are highly dependent on the weather parameters, especially temperature, relative humidity, and leaf wetness. So we think that this part is very important. And we would also like to apply this in other regions of the world in order to broaden the model's applicability, to include other characteristics, other crop types as well. That was all from me. Thank you very much.
Thank you. Let's move on quickly because we're running over time. Do we have Miss Lulioli online? Is she available?
Yes.
Okay, let's try again.
Yeah.
So, Ms. Lulio will talk about the assessment of autonomous mower effects on Phyla nodiflora and pollinator presence in urban lawns. Please go ahead. Please try again.
Okay, now you see the presentation.
Go ahead.
Okay. Good morning. I'm going to talk about my PhD research about the assessment of autonomous mower effect of Phyla nodiflora and pollinator presence in urban laws. Here a small introduction about the importance of residential yards. It is increasing in terms of the potential impact on the ecosystem service and overall well-being. And residential parks are essential also for bees and other pollinators. So in this research, we wanted to go in depth in this aspect. In addition, there is a critical need to examine turf management practices, such as mowing, for example, and the integration of biodiversity. For this reason, we try to use Phyla nodiflora in residential garden. Here you can see an image of autonomous mower that are becoming more and more important and popular in residential law. And the most common navigation system of autonomous mower is the randomic pattern. But now with the systematic pattern, we can reach more efficiency in terms of time and coverage of mowing activity. For this reason, gaining information on the impact of law management with autonomous mower on the floristic composition of laws has the potential to improve the biodiversity of this common type of green space, very important in many cities. Phyla nodiflora is a perennial species with a prostrate root tendency that belongs to the Verbenaceae family, and it is frequently visited by pollinators. As observed in previous studies conducted by my colleagues, Philanodiflora seems to be suitable for the autonomous mower activity that is characterized by high moving frequency and also low height. From what is observed in previous tests, the Lipia, despite having obtained the best results with ordinary management, characterized by a reduced cutting frequency, seems to adapt also to frequent cutting, like that of autonomous mower. For this reason, we want to test the effect of systematic trajectories in terms of benefits both on the Philanodiflora and also the benefits for the pollinator species. The trial is performed at the experimental site Potere Rottaia in Pisa. It was performed from the first year from June 2024 to September 2024. And at the beginning of the trial, the turf grass composition was characterized by the species that you can see in this slide. The Paspalum, Bellis perennis, Trifolium, Medicago, Lupulina, Taraxacum officinale, and Cynodon dactylon. That it is a typical species of turf grass in Italy. The management system compared were mowing performed by the autonomous mower with systematic path planning and cutting gait of 3 cm, mowing performing by the autonomous mower with systematic path planning with 6 to 8 cm, and then mowing performed by autonomous mower with randomic path planning and the same aids. And then there was also an area with no mowing intervention to have a control area. In each plot were transplanted in total 8 plants of Philanodiflora. 7 carrots were of 8 cm and a bigger one in the center of the area, characterized by an area of 25 cm. The parameters assessed were the surviving Philanodiflora individuals per plot, species coverage per plot, and number of Philanodiflora flowers per plot, flower state, and at the end, the number of pollinators. In this slide, you can see the first and preliminary results about the 8. It is evident that the highest state was in the systematic maximum 8 beyond the control, with an higher average 8 in September. The minimum 8, however, was detected in the thesis with random minimum 8. In this slide, you can see the results about the species coverage, and as you can see, this Cynodon dactylon is the one that covered the most. Over the months, the Lipia rose from 2.55% to 3.4%. The one of that rises the most is the Cynodon, as we expected, and we had also a decrease in width percentage, except for the Paspalum dilatatum, which decreased in the month of July, and then again probably due to the high temperature in summer. In this slide, you can see the results about the number of pollinators that we observed by site, remaining for 15 minutes in each thesis, and 3 observations were conducted. The highest total number of species occurred in the month of June, where the various flower plant species were present, which probably influenced the visit of the pollinators, also on the Lipia. From the results obtained, it is also noted that the number of insects observed is greater in the afternoon than in the is greater in the afternoon, probably due to lower presence of dew and lower average temperature during the day. In this analysis, all the pollinators were counted without yet specifically analyze the number of individual species to also get an idea of the biodiversity rate. These analyses will be conducted in the future, also with the results of the second year of the research. As conclusion, we can see that the initial hypothesis was confirmed. So the Phylanodiflora adapted well to the high mowing frequency and low cutting gait because the Phylanodiflora can have a very low flower rate and can adapt with an horizontal development to the mowing activity of the robomower. In addition, higher turf grass minate of turf grass managed with systematic pattern with higher mowing gait was obtained due to the lower tramping activity and overlapping of systematic pattern. The frequent cutting activity of autonomous mower favored major the Cynodon development and decrease in width and number of clover flowers. The lower overlapping of systematic pattern caused less stress of the leaflet plant. So we had a higher number of insects on Phylanodiflora mowed with systematic pattern. Further analysis will be conducted regarding the number of flowers in each species and also appunto l'analysis of trajectory of autonomous mover will be very useful to assess the real presence of the autonomous mover on the Phylanodiflora. And we also want to conduct a quantification of the biodiversity due to the use of image analysis with YOLO. Thank you very much.
Thank you very much. Do we have any questions? Okay, I have a question here, which is there a particular interest in lawns? I mean, why are we considering lawns as so important here? I mean, perhaps from a biodiversity perspective, we shouldn't be promoting lawns. Let me suggest that.
Because lawns are very important also in the cities where the biodiversity rate is very, very low. And in addition, they constitute approximately 70 and 75% of urban green space globally. So we have to use new species to increment the biodiversity rate and not use only one species that it is very common, for example, here in Italy in historical garden or also in residential garden.
Yeah. I understand. I was just trying to suggest that perhaps lawns is not the right way to promote biodiversity. All right, thank you very much. We are running rather late, 15 minutes over time. This concludes the session on digital tools, crop and tree production, and we are going straight into session 7, digital tools, and I think somebody else is chairing.
No? Now? Looks like it's been activated now. Welcome everybody, and we will proceed on the next session right now, and I will be chairing this section, and hopefully this is a section of digital tools. As my father says, I hope that we will hear some good presentation, and that these digital tools, some of these will be available not only to the scientific community, but to the end users, farmers, students, etc. So, with that said, the first presentation is an oral one, and I will invite Mr. Yannis Marketakis from the Foundation of Research and Technology North in Greece, and he will present us a topic on transforming FoodX to a standardized and interoperable thesaurus. It's difficult for me to understand that. So Yannis, please go ahead. And I will warn all the audience 2 minutes before and 1 minute before with the time.
That's
Thank
great.
you. Please
So,
go ahead.
Thank you very much. I will try to make it easy, not only for you, but
Do
for
your
everybody.
best.
So, good morning. My name is Yannis Marketakis. I am a research and development engineer in the Institute of Computer Science in the Foundation of Research and Technology. And I will present you our work towards constructing a standardized and interoperable thesaurus for the food domain. So this is what the way I will try to spend my 10 minutes. I will start from an introduction, then I will move on to the motivation of our work. I will tell you a little bit more about this thesaurus, and we will conclude with some results. So do we have people in the audience that are not from Greece? Please raise your hand. Just 1, 2. Okay. Do you know what this is? So it's quite popular then. Yeah, tzatziki. Tzatziki is a very popular dish, a starter dish here in Greek restaurants. We call it tzatziki, but it's not the usual name for tzatziki. It is called many, many different names in different countries, in different languages. So it has many names. And that's the problem with food items. They don't have global names. So how do we refer to them? To solve this issue, the European Food Safety Authority created FoodX 2. FoodX 2 is an hierarchical system that is used for classifying and describing food products. It is organized into terms which describe the food items and facets that are used for describing different features of these items. It is an hierarchical system. And here in the lower part, you can also see the hierarchy of tzatziki, so how it is classified. And a screenshot from one of their products for visualizing FoodX 2. So, although FoodX 2 is quite popular in the food domain, the food science domain, it has several limitations as it is right now. The most apparent one is that it is missing global and unique identifiers. For example, FoodX is identifying food items using 5-digit codes. So if I provide you with this code, A02MB, probably it means nothing to you. But if I tell you that this is a FoodX 2 code, then this makes a difference. So codes in FoodX 2 make sense only in the context of FoodX 2. It's not, for example, a URL that you can always click and see the results in your browser. So it's self-explainable that way. And because of these limitations in terms of their identifiers, it has limited interoperability, which makes it difficult for other public knowledge bases and databases to refer to it. Of course, it's not machine readable because it does not rely on an ontology or another schema, formal structure with clear semantics in order to describe it. And the last thing is that it requires dedicated applications to access it. And for this reason, the European Food Safety Authority has created 2 applications, the Catalog Browser and FoodX 2 SCA, in order to access it and use it. On the lower part, I don't know if you can see it, this is a criticism about FoodX 2 from one of the advisory members of FoodX 2, of the European Food Safety Authority. Sorry. So they criticize FoodX 2 for these reasons. So what we did is that we relied on a W3C recommendation that is used for constructing and organizing knowledge. It is called Simple Knowledge Organization System, SKOS, and tries to overcome all these problems that we identified that FoodX 2 has. SCOS has a relatively simple structure, so it organizes everything into concepts, and concepts can have different relationships between them. So here, for example, you can see that we have three different concepts, a cat, a mammal, and an animal, and these concepts have different relationships. So we can say that a cat is a broader term of a mammal, and it is a broader term of an animal. We can have different labels, preferred labels, so how do we prefer to call these concepts in different languages? So SCOS has natively multilingual support, and all of it is organized into a concept scheme. So everything starts with what we call the mappings. So what we want to do is that we want to create an interoperable thesaurus that will be described using SCOS from the original version of FoodX2. So we start describing mappings. Here you can see an XML version of FoodX2. So the first thing is to say which are the concepts for us. So every term that we see in FoodX2 for us is a concept. And then we start defining the properties. So everything that is found under term code, it will be the identifier for us. The extended name will be the preferred label, and so on and so forth. And of course, we also move on with the hierarchies that way. And this is the technical process. So having defined all the mappings, so how do we map from FoodX2 to SCOS FoodX2, as we call it, we have implemented a transformation workflow that takes as input the original version of FoodX2 as it is. It uses those mappings to create the SCOSified version of FoodX2. Now this workflow is fully automatic, and the main advantage of this approach is that it allows the maintainers of FoodX2, so the European Food Safety Authority in this case, to continue to support FoodX2 the way they do it now. So they continue to update FoodX2 using their own structures, their own tools, their own procedures, and we just run this workflow in order to create the new version of SCOS FoodX2. So it's totally compliant with the addition, the removal, and the updates of new concepts in FoodX2. And of course, it's valid as long as the schema of FoodX2 does not change, which is something that does not happen frequently. Now, the benefit is that now, having described FoodX2 using a W3C recommendation, such as SCOS, we no longer need dedicated tools to access it. Remember that the European Food Safety Authority has developed two specific tools to access it. Now we have a plethora of tools to access FoodX2, from SCOS editors to online browsers, programming libraries, visualization tools, query languages, so we can use whatever we want. And from this plethora of tools, I just show here just two of them. The first one is SCosmos. It is an open source tool that is used for visualizing SCOS thesaurus, SCOS vocabularies. And here you can see, for example, the description of one of the items in FoodX2. And the second one is a generic visualizer of semantic web resources, the RDF visualizer. Apart from that, to prove that it is very efficient to do whatever we want with SCOS FoodX2 now, we configured one of the web applications that we have to support searching and accessing SCOS-based knowledge bases in order to demonstrate how we can search and access SCOS FoodX2. So you can also use it and browse it. I also have a link at the end, but this is also a link here. So here you can see, for example, the term, the tzatziki term. It's my running example. The different facets, the hierarchy, and external references. Pretty much everything that already exists in FoodX2. To summarize, what we have presented and what we have described is that we have implemented SCOS FoodX2, so not only an interoperable thesaurus, and that is described in a standardized format using semantic web technologies and SCOS, but also a workflow that supports the automatic reconstruction. Whenever FoodX2 has a newer version, we just re-execute the entire workflow, and we have a newer version. In future, we plan to support the automated linkage of SCOS FoodX2 with external sources. So there are many different knowledge bases like FoodOn out there, so we can link these two together. And of course, we plan to support an ontological version of FoodX2 that will allow us to have richer semantics on our description. Now, this work was carried out in the context of a project that we carried out with the European Food Safety Authority, and it was carried out last year. This is the member of the people that, the group of the people that participated in the project and in this publication. Apart from me, it was Athina Kritsotakis, Anastasia Xaridou, Pavlos Falios, Michalis Mintandonakis, and Yannis Zizikas. Here you can see the URL for the web application. You can use it. It's publicly available, so feel free to use it. Thank you very much for your attention.
Thank you, Yannis. You're very good on time. So 8 minutes, 49 seconds. Any quick questions, please? Christopher and... sorry? Yeah. I think, yeah.
Okay. Yeah, I mean, Foodex has been around for a long time, and Foodon claims to have entirely linked to Foodex. So I'm curious why EFSA, and from your perspective, what the motivation is, in effect, to duplicate the work that Foodon has already done, because at least in theory, Foodon covers everything that's included in Foodex. In Foodex 2. So, I mean, either your motivation or EFSA's motivation, I'd be interested to understand what's going on there.
Well, first of all, yes, you are right that Foodon has some links. It's not actually links, because Foodon is a knowledge base. It has URIs, URLs. But Foodon has descriptions pointing to Foodex. So they have a concept, Tzatziki, for example, and they say that the code in Foodex 2 is this one, the code. So it's not linked, it has some descriptions. But as regards your question, I think it's a political issue. So Foodex 2 was created by EFSA. Foodon was an open project, and it's publicly available. So they are not very keen on using Foodon. They prefer to use Foodex.
Okay, thank you. Ms. Aphrodite has a question.
Well, more or less, my question is on the same concept. I would like to ask, who is the final user of this application, apart from the researchers and all that stuff? And I'm wondering if EFSA itself has adopted this application in order to disseminate or, put the lights on this interesting work of yours. And if you happen to know if other ontologies have been created depending on the same knowledge base of EFSA. So are there any competitive applications like yours that are existing?
Okay, so I'll start from the first question. The first question was if EFSA is using it. EFSA uses it. We implemented that last year because EFSA wanted to migrate all their knowledge into an ontological version, as they call it, in the wider spectrum of using AI, symbolic AI. So we implemented that, and the overall purpose was that EFSA was about to use it from now onwards. So whenever they refer to Foodex 2, they will start referring to this cosified version of Foodex 2. That was the initial idea. Now, apart from the scientific community, it's openly available, so anybody can use it. But I think because of the contents of Foodex 2, it's mostly focused on the food science domain. So it's scientists from that domain. And moving on to the last part of your question, SCOS is a W3C recommendation. We relied on SCOS. So whenever he wants to create a thesaurus, a vocabulary, whatever he wants to create, he will use SCOS. So it's something that it is, widely used. We relied on this because basically it's a recommendation from W3C. Our job has not yet been used to lead, as far as I know, because it's a very recent job. We finished the project last year. We created this publication now, so it will begin to, to expand.
Thank you, Yannis. Very thorough. Thanks. Yeah, we have one more question on the...
Great presentation, Yannis. Thank you very much. You may probably mentioned it in the beginning. I may probably missed it. What is the format in which Foodex is available by FSA?
The original version of Foodex? Yes. It is available in XML format, and in another format, because it's a duplicate, let's say, format, for which we didn't have any access. It is a format tailored to their application, but we use the XML version.
Great, thank you.
Thank you, Giannis, again. Now you can go and have a coffee. The next, no, just coffee first. The lunch is later on. The next presentation, it will be online. I hope we will get it on. And it's presented by Mrs. Efrosini Bitakou from the Agricultural University of Athens, according to the schedule here. And the title is Current Status of Augmented Reality Marketing in the Food and Beverage Industry. So hopefully she will be there.
Are you able to hear me?
Yes, Mrs. Efrosini, welcome, and please start on. I will warn you 2 minutes before the 10 times. Thank you.
Thank you very much for the introduction. Good morning, everyone. Welcome to my presentation. First of all, let me introduce myself. My name is Efrosini Bitakou, and I am a PhD candidate at the Informatics Laboratory of the Agricultural University of Athens. As you can see on the screen, our research study is the current status of augmented reality marketing in the food and beverage industry. To begin with, it is necessary to underline the objective of this research. This study aims to identify the current literature research of augmented reality marketing implementation in the food and beverage industry. In this slide, you can see that the presentation starts with the background of extended reality, augmented reality, and augmented reality marketing. Then I will go on to highlight the motivation of the research and the methodology that was followed. And finally, I will focus on results and conclusions of the research study. It is worth noting that extended reality is a broad term that includes augmented reality, virtual reality, and mixed reality. In this research, we will focus on augmented reality, which lies between the physical world and mixed reality. Especially, augmented reality can be widely regarded as one of the most exciting cutting-edge technologies that rapidly gains popularity. Currently, it has been applied in different sectors such as education, medicine, and retail. At this point, the definition of augmented reality marketing is provided according to Rausnabel et al. To elaborate on that, augmented reality marketing represents a novel marketing approach offering customers innovative features to enhance various aspects such as trying before buying a wide variety of clothing, makeup, and other items without having to interact physically with them. Also, it gives the opportunity to take a virtual tour of the physical location on consumer smartphone. And finally, augmented reality experiences could use real-time data about the customer preferences. Therefore, the following research question arises. Why is augmented reality marketing significant for the food and beverage industry? In this context, the main research question is analyzed further into 3 sub-questions. Firstly, what is the overall evolution of the research landscape regarding augmented reality marketing in the food and beverage industry? Secondly, which approaches and methodologies are being utilized? And thirdly, what is the context of application of augmented reality marketing in the food and beverage industry? Throughout the study, a review of the state-of-the-art of augmented reality marketing, focusing on the food and beverage industry, was conducted during the period May and June 2024. The adopted methodology consists of 3 parts: a systematic literature review conducted based on Prisma across 2 scientific databases, namely Scopus and Web of Science. The search employed a combination of relevant keywords such as augmented reality, marketing, food, and wine. The search included journal articles or conference papers written in the English language. It is significant to underline that no limitation was applied to the year of the publication, given the fact that the novelty of the research topic. Following up on what I just mentioned, this slide presents the systematic literature review conducted based on Prisma.
The analysis identified 7 studies that are included in both databases, and as a result, 26 studies were assessed as eligible. Now, moving on to the results, despite the promising potential of augmented reality marketing, the research in the food and beverage industry remains limited. The systematic literature review conducted based on Prisma returned a total of 26 studies published from 2011 to 2024, with most of them being published from 2017 onwards, as illustrated in the graph. Among the studies, 62% are journal articles, and the remaining 38% are conference papers. Additionally, regarding the approaches that are being utilized, the empirical approaches dominate. The remaining 23% are theoretical and mainly are literature reviews. Furthermore, the quantitative methodology dominated the field. Especially, 92.3% of the papers adopts the quantitative research design, such as questionnaires, experiments, and reviews. 3.84% of them uses the qualitative research design, such as interviews, and only 3.84% of the corpus deploys the mixed research design, that means both of the methodologies. Now, regarding the country where each study was carried out, most of the studies are not country-specific, but they are product-specific. The results show that most papers have mainly focused on the products such as chocolate, milk, vegetables, wine, rice, iced desserts, and meat. Regarding the context of application, augmented reality marketing is mainly deployed for interactive information on-site or online, for supporting the provision of nutritional data on food packaging for consumers in order to select products, to facilitate healthier dietary choices, and enhance the cooking and food shopping experience. Additionally, augmented reality is used to evaluate consumer behavior such as decision-making and brand perception, while also attracting attention to products. In sectors like wine tourism, augmented reality enriches visitor experiences, and it augments physical brochures for purchasing agricultural machinery. It also enhances product visualization, whether for online restaurant orders or showcasing different product combinations in retail stores. In summary, we can conclude that in the context of utilizing augmented reality for marketing purposes, the food and beverage industry currently lacks extensive analysis. Augmented reality marketing is more than just another trend. It stands to be one of the most promising strategies for businesses over the coming years. As a result, the demand for sustainable, high-quality, and safe food products is pressing businesses in the food and beverage industry to deploy innovative technologies. Also, augmented reality transforms how food and beverage companies engage with customers, offering personalized connections with them, making products stand out. Therefore, future research will focus on the profound analysis of application types and development tools, and also challenges and limitations of augmented reality marketing within the food and beverage industry in inquiring. Thank you for your attention. I'm happy to answer any questions you may have. Thank you very much.
Mrs. Bitaku, you kept perfectly the time. That means we have time for a few questions. My only little comment is, it's a curiosity comment, why beer was not included on the beverages? So please, any questions from the audience?
Okay, thank you.
I thank you too. I wish you good luck in your studies as well. Bye-bye. That's good. Now we will proceed, and in the next presentation, which is an oral one, by Mr. Hercules Pantsopoulos from the University of Maastricht in Netherlands. Welcome, Irakli. And he's presenting on behalf of a team of people, among them Christopher Webb is here. So
Unveil the secrets of embeddings. Hercules, does the importance of agricultural terms, and so on. Please continue.
Kalimera, good morning to everyone. A quick question. How many of you use ChatGPT? Okay, so I suppose you know what ChatGPT is. It is a large language model. We will refer to large language models. It's great to present our work after the presentation of the work in Defrosini and Yannis. There are some overlaps, at least, with the work presented by Yannis. I'm here today to tell you the work we did with the support and help of Christopher and my good colleagues Panagiotis and Sue from the Agricultural University of Athens and the University of Maastricht. This is the outline of the presentation. So let me start with some background information and the motivation that led to our research. Let's start with some facts. We all agree that the field of agriculture or the agri-food domain has become knowledge intensive in the past few years. And it's highly dependent on the data and information that is being produced by various sources, and capturing this information in a timely and efficient manner is very important. Apart from that, there are also two basic pillars upon which our work is based. Pillar number one, there are great powers, if I could say so, that are being provided by language models, and we can extend this to large language models, given the fact that they are based on transformer technologies. Transformer technologies were introduced back in 2017, but they have been very influential because this is the technology that underlines all these models. And these models provide great affordances for capturing the semantic context in which words occur in text. So this is one pillar. A second pillar relies on the fact that for various applications and purposes, we need to use ranked lists of terms and context that may be found in text. One such application could be to prioritize new concepts to be added in a knowledge base. So, how are these two pillars come together? Up until now, we rely on quantitative methods in order to measure how important a term is in text. And the most popular quantitative measure is TF-IDF, which is based on mere counts of words in text and in a corpus respectively, which means they completely ignore what are the other words that appear around or in the surroundings of a term. So, having said that, it is valid to assume that the semantic context in which a word appears does play a role in its importance. To the best of our knowledge, this is a part of research that has not been touched upon a lot. So, the research question is something we could probably suspect, but we wanted to shed some light on it. Is there a relation between the importance of agricultural terms and the semantic context in which these terms occur in text? By context, as I already told you, we mean the semantics of the text in which the term occurs, and those semantics are encoded in real valued vectors that are outputted by those language models. And the way these real valued vectors are mentioned in literature is by using the word embedding. So these vectors are called embeddings. The problem with these embeddings is that if a human takes a look at them, she or he will not understand a thing. They are vectors of real valued numbers having to tell us nothing at all. So the way we use those vectors in scientific applications is by computing the semantic distances of those based on cosine similarity. And the computation of such semantic distances is the way in which conversational question and answering applications currently work. As you will be able to see in the results section, we based our research on such semantic distances and more specifically on the semantic distances that various occurrences of a concept in a corpus may have. This means that in a corpus of texts, a concept may occur multiple times, so we can compute the semantic distances of those various occurrences. We also used the semantic distances of a concept and and the text in which it occurs, and also the semantic distances of different texts in which a concept occurs. You will see all those semantic distances in a bit. This is the broader context in which our work is focused. We are doing work that relates to the automatic update of knowledge bases starting from available text corpora. Knowledge bases like Agrovoc, which is another SCOS-based thesaurus, as the work that Yannis Marketakis presented a few minutes earlier. So our broader work relies on the fact that we can automatically extract terms from a corpus of texts, and after identifying novel terms in those texts, rank those terms according to their importance, and provide recommendations about new concepts that could be added in a knowledge base, like Agrovoc. So it is very important to be able to compute the importance of new concepts and make such recommendations. And to compute the importance of terms, it is nice to know whether the semantics of those terms could play a role. This is the methodology of our work. We started from the Agrovoc vocabulary, from which we extracted Agrovoc concepts. We used those concepts in order to retrieve abstracts of texts from the Agris database, which is a side project of Agrovoc. Those texts were used in order to compute the importance of concepts, of the Agrovoc concepts occurring in it. Of course, we had to rely to TF-IDF in order to compute concept importance. And then, using a language model that is pre-trained on agricultural text, we vectorized those texts, and we used the text vectors, the embeddings, in order to compute the semantic distances I told you about and calculate correlations between concept importance and those semantic distances. Here you can see some basic statistics about our dataset. We used 50 unigram concepts that were randomly extracted from Agrovoc. Based on those concepts, we were able to retrieve approximately 33.7 K Agris abstracts, which were indexed in Agris between 2023 and 2024, and we applied some basic text cleaning and pre-processing methods before using our text for our work. You can see some numerical facts. For example, the minimum length of a text was 20 words, the maximum was 350 words. An abstract contained at minimum, a text contained at minimum 1 concept and at maximum 4 concepts, and the other facts are there in the table. In order to vectorize our text, we used BERT. BERT is a language model that is based on the Transformers technology, and more specifically, we used a variation of BERT which is named Agriculture BERT and is a language model particularly pre-trained on agricultural texts. BERT has a limitation. It can encode 512 tokens, which means that there is a limit to the text you can provide to it as input. And this is the reason why our texts were limited to 350 words. BERT outputs vectors for each word you provide as input to it, and a special vector that is outputted by BERT is the CLS token, which is a vector representing the whole text. And that vector was used as a representation of the whole text we fed into BERT. We used also min pooling in order to create the embeddings of a concept, because when you feed text into BERT, words are split into smaller parts. And as I told you before, the semantic distances were computed by using cosine similarities. So keep in mind that high cosine similarities mean small semantic distances. The higher the cosine similarity, the closer two words or two texts are in terms of the semantics they carry. Here you can also see some evidence about the TF-IDF scores that were computed for a concept. Those values you can see for TF-IDF scores are low because of the fact that for each concept we computed its importance for the whole corpus, which means that we had to average the importance of a concept for all the texts in our corpus. And you can also see the different values we were able to compute for the various kinds of semantic distances we computed. So we had an average of 0.1957 for the semantic distance of the various occurrences of a concept, and so on. Let me quickly present you the results of our work. We were able to to identify a tendency towards a semantic correlation between TF-IDF scores and the semantic distances between the various concept occurrences. It was slightly above 0.05. The same applies to the correlation between TF-IDF and the semantic distance between a concept and the text it occurs. We didn't manage to identify a semantic correlation between TF-IDF and the distances between the various texts that contain the same concept. Of course, it is worth to mention that all those semantic distances we used as a proxy for the context in which text occurs are significantly correlated to each other. I will give you, before closing my presentation, a spoiler of the follow-up of the work we already did. We have already started some next trials, which are also based on Agris abstracts. However, in this case, we have changed our methodology a bit. We didn't start for concepts initially extracted from Agrovoc. We started from 3K Agris abstracts, which were extracted from the Agris database, and we computed those correlations using Spearman's Rho for a random sample of 100 agricultural terms. So we somehow reverse engineered this approach. In this case, in most cases, we were able to identify semantic significant correlations up to a level of 0.001. So I will stop here. I would also like to thank the EU Farming Project, which has partially funded this work. Thanks a lot for your time.
Thank you, Hercules. Any quick question, because we ran 1 minute of time? Any quick question from the audience? If not here, then in the lunch.
Thanks a lot.
Thank you, Hercules. Good work. We proceed on the next one. This is another online presented by Mr. Pavel Ambrus from the Czech University of Life Science of Prague, Czechia. I would like to welcome Mr. Ambrus, Dr. Ambrus. The title is Security Aspects in the Agricultural IoT Infrastructure, Network Segmentation and Security Infrastructure. So welcome, Pavel. I will warn you 1 minute before your time, so please go ahead.
Okay, thank you. Hello, my name is Pavel Ambrus, and I am from Czech University of Life Sciences in Prague. I would like to introduce our paper, Security Aspects in the Agriculture IoT Infrastructure, Network Segmentation and Security Infrastructure Perimeter, by Pavel Ambrus, Vladimir Voral, and Associate Professor Michal Stoches and Jiří Vaněk. Acknowledgement. This work was supported by EC Horizon Euro funding in the project CODES grant 101060178. The results and knowledge included herein have been obtained owing to support from the following institution grant: Internal Grant Agency of the Faculty of Economics and Management, Czech University of Life Sciences, Prague, grant IGA 122-3B005. Okay, the outline. Methodology, challenge of IoT in agriculture, benefits of segmentation, endpoints, security implementation, and some conclusions. Methodology. Our research focused on ensuring the security of IoT infrastructure. To achieve the best possible results, it is essential to understand the infrastructure as a whole and analyze all its key components. To implement appropriate security measures, it is first necessary to identify which attack vectors are used by cyber attackers. For this purpose, we deployed a simple honeypot. at the edge of the infrastructure to collect data on any attempts to compromise security. Based on the data collected from the honeypot, we will design security rules for the firewall. We will then replace the honeypot with a firewall configured by us at the network perimeter and continue to monitor by potential vulnerabilities to ensure that our security is aligned with industry standards in cybersecurity. We will compare this the collect data with the findings of leaders in the cyber field. As can be seen from the right slide of our presentation, the first step is the collection of raw data, then compare the data and set our security settings to our router or firewall. Then we test this router or firewall, and we have maybe some results. Okay. IoT. How to protect the IoT infrastructure is difficult because IoT in agriculture involves thousands of devices. Agriculture IoT segmented into fields, greenhouses, forests. IoT networks are very large and complicated to manage. Another problems with endpoints is an abundance of different devices, managed and unmanaged devices. Many manufacturers or suppliers, almost every device requires a different type of connection or configuration. Segmentation may be a simple matter for someone, but it isn't essential. It is very beneficial because separate networks improve security and manage access efficiently. Appropriate division of IoT into greenhouse, forest, field. Security. With segmentation, we can implement security rules. Security on endpoints is also not very easy because not every device can encrypt traffic. Unknown devices on the network, availability of data from IoT infrastructure, segmentation that is provided with rules. Someone could argue that almost all traffic from IoT is encrypted and there is no need to deal with segmentation or authorized access to the network. But it's necessary to realize that IoT infrastructure in agriculture are very large and administrations often do not have an overview of where what is and what everything is connected in the network and whatever everything communicates to the correct system. The easiest thing we can do for minimal network security is to segment the infrastructure and implement communication rules between devices. Conclusions, the infrastructure needs to be provided as a whole, and several important aspects need to be considered already during the design. I think secure infrastructure is clear concept of infrastructure, adequate segmentation for the given concept, definition of access rules for data and devices. The following research future deals with the security of individual device in IoT and the monitoring of the ensured infrastructure, since the most important thing is to know what is found in the given infrastructure and where it communicates. That's all for me. Thank you for your attention.
Thanks a lot, Pavel. You handled a very important in the future and currently topic, and you were the best one on timing, 6 minutes, 31 seconds. So that saved a lot. Probably some questions from the audience. They all feel safe after what you said, I guess. Any quick question? If not, I welcome you. You have a good time in, are you in Prague right now?
Yes.
How's the weather there?
Little bit cloudy.
Okay, It's much better here in Greece, in Samos Island. So take care. Thanks a lot. Let's move.
Thank you. Bye-bye.
Bye-bye. The next one, we are running on the middle of our presentation. It's going to be an Italian lady, Mrs. Giulia Maesano, from the University of Bologna in Italy, exploring consumer intentions to purchase blockchain-traced pasta. Italians are the best in pasta. So welcome, and please go ahead.
Good morning, everybody.
Is it on?
Okay. Good morning, everybody. I am Giulia Maesano, Assistant Professor at University of Bologna, and today I'm presenting a work that explores the consumer intention to buy blockchain-traced pasta. This work is developed in the framework of a research project with my other co-authors. The motivation behind this study is that traceability is a key element in avoid the food fraud and also help to increase the trust, consumer trust in the product. In this context, the blockchain technology appear to be a promising tool in order to enhance the traceability and also the trust of consumer toward the product by the decentralized and immutable transaction and movement of the product across the supply chain, starting from the raw material to the end final product. But, however, despite its potential, the use of blockchain for the traceability in the agri-food system is still limited. And so we think that there is a need to further explore the consumer purchase intention toward the blockchain based traceability system and compare also to the existing solution. So this study aims to investigate the consumer intention to buy organic pasta traced with the blockchain system and using the theory of planned behavior framework. The theory of planned behavior is a conceptual framework that helps to explain and predict the human behavior. Has been successful used in the context of food choice and help in predict consumer behavior and intention toward especially organic product. The theory suggests that individual behavior results from three constructs: the attitude, the subjective norm, and the perceived behavior contour that are good predictors to shape the intention and also the behavior of consumer. In this case, we suppose the attitude toward the safety and authenticity of the food product, subjective norm are the social pressure, and perceived behavior control, we means the perceived behavior control such as the perceived easy or difficult to identify the food fraud or avoid food fraud. So the more favorable these components are, the stronger the intention, of course, will be. However, we decide to go beyond this framework, putting also two new variables. So we opt for an extended model. So apart the subjective norm, perceived behavior control, and attitude, we decide, according with the previous study and so the literature, we decide also to put in the model the trust toward the quality certification and attitude toward technology, because according with the previous study, these are important predictor in shaping the intention to buy a product that is stretched under the blockchain traceability system. So our hypotheses are that the social norm, perceived behavior control, the attitude, trust toward the quality certification, and attitude toward the technology plays a significant and positive effect in the intention to buy a blockchain traceability product. So we conduct a survey using online questionnaire disseminating using the social media on a sample of 201 Italian respondents, obtain a final number of 190 valid response. We use social media, and as a recruited method, we combine convenience and snowball sampling. The questionnaire is structured with several sections, starting from the introduction. Another section aims to investigate the consumer knowledge about the traceability in general, and also the knowledge about the blockchain system. And another section related to theory of planned behavior construct in the extended version, so with the other two new construct. And the final section aims to collect social demographics characteristics such as age, education, gender, level, and income. These are the items that we use to measure the construct related to the theory. We, of course, use a validated scale and previous study in order to construct this item that help to measure the construct. We start with Cronbach alpha to assess and evaluate the reliability of the construct. So in order to be sure that the items are very correlated, so the item measure the same construct. And after, we conduct a structured equation model to test our hypothesis. The SEM is a set of integrated multivariate technique that is used in the literature to explain multiple interaction between multiple latent variables, as in this case. So if you look to the Cronbach alpha that we use to measure the reliability of the questionnaire, we can see that we obtain an overall good score for each construct, because as we know, Cronbach alpha say between 0 and 1, and a good score is around 0.7, so we can consider a very good reliability in the questionnaire, because all our items obtain a very good score. So this means that the items are very correlated. With a look to our result, we can assume that our hypothesis relate to the social norm and perceived behavior control and the attitude toward technology are accepted because they receive a positive and significant statistic results. So this means that these constructs play an effect in shaping the intention to buy the organic pasta under new traceability system. On the contrary, the attitude and also the trust toward the quality certification are rejected because they are not significantly statistic. So these results are in line with a previous study that found that the attitude toward technology and perceived behavior control social and the subjective norm are a good predictor, and this was already found in a previous study. However, also the results regarding to attitude and trust toward the quality certification that are not relevant, not significant statistic, are in line with previous study. So we can conclude that the average consumer in our sample has a positive perception of blockchain, so a positive attitude toward the purchasing product that use blockchain technology for the traceability can be deduced. So nowadays we can suppose that the blockchain technology has the potential development from the perspective not only by producer but also for consumer. And to conclude, our study, of course, presents some limitations. First, about the sample, because it's not a representative sample. So we would replicate the study using a representative sample of the population in Italy. And another future study could be also interesting, replicate the study using non-hypothetical condition. And so, for example, another method, such as, for example, experimental auction, that can be useful also to replicate the study and compare the result from a non-hypothetical condition and replicate with a result from our study. So thanks for your attention, and I don't know.
Thanks a lot. You were also very close, very good in time. That saves a few questions. Now, the word pasta already turns our appetite. I hope for questions as well. Anyone? Did you raise your hand or no? Okay. I have not question actually. You said organic pasta.
Yeah.
You mean that pasta that was produced from organically grown durum wheat?
Yeah.
the customers, the consumers who are using these are finally processing it and eating it. Are they sure that the other products that they will add in the organic pasta will be organic as well? It's a curiosity question.
Yeah, we opt for organic pasta and not conventional pasta for this reason, because a lot of people decide to avoid to buy organic pasta because they don't trust in the organic process, because about the raw materials.
Blockchain assures that
exactly.
They will be.
So we decided it is a
another curiosity: how much more expensive as compared to the regular one is? Any estimate? 10%?
Yes, there are, at least in Italy, some company that already send organic pasta under blockchain traceability system, and is 20-30% more than conventional one.
That's reasonable.
Yes.
Thank you very much.
Thank you. Thank you.
Okay. We will proceed on the next one, which is an online by Mr. Nikolaos Avgoustis from the Ionian University of Greece. And Nikos will talk about modeling wildfire spread based on plant moisture content data from dense, low-cost sensors and meteorological data. So, Mr. Nikolaos.
Good morning, everyone. I hope everyone can hear me fine. I will start by introducing myself. I'm Mr. Nikolaos Avgoustis. I'm a PhD candidate in Ionian University at the Department of Informatics.
Nikos,
and I will present a work.
Sorry, 1 second. We cannot see your presentation. Just give us 1 second. The technical personnel will take care of that.
Of course.
And I'm not going to count this time. Don't worry. I will start counting when you start talking. And I will warn you, Prof, around 1 minute before. So give us a few more seconds. Hopefully, this is a technical issue. And in the meantime, you can say something about this work. Just a few keywords. Okay, go ahead, Nikos. We are set. Thank you.
And as I was saying, I will be presenting our work on modeling wildfire spread based on a dense network of low-cost sensors. The sensor we will be using to perform this action was presented in a previous session, session number 6, by my colleague Nikolaos Polymenakos. And I will just display another way to use the network of the sensors to perform another action than it was intended. So, what are the challenges in wildfire spread prediction? Traditional fire spread models rely on static data and assumptions, particularly regarding the plant moisture content. Our study here highlights the potential improvement from using real-time data, specifically for moisture content, and we will try to prove that by using cellular automata simulations. The role of plant moisture spread in fire. The plant moisture in fire spread. Moisture content is a crucial factor in how plants ignite and burn. Lower moisture levels make plants more flammable and accelerate the fire spread. Also, current models, as I said before, often rely on outdated assumptions about moisture, which might result in underestimating the fire spread or intensity. Here we can see the results of a theoretical model proposed by Mr. Richard Rothermel that display the connection between the moisture content and the rate of spread, also the minerals in the plant. So, why real-time data? Real-time sensor data would allow us to continuously update and reflect immediate changes in an area's plant moisture and other environmental conditions. This would result in a dynamic fire spread prediction, helping adjust fire management strategies more quickly. So, while we haven't yet deployed our sensors, our simulations highlight how the differences in moisture levels affect the fire spread. The goal here is to demonstrate how real-time data would improve the spread predictions and the response times on managing them. And just as an example, I will share here two simulation scenarios on the same simulation step, on the same grid configuration, with the only difference, the moisture content. The left one has lower moisture content on the plant, and the right one higher. And as we can see, on the same simulation step, on the left one, we have more burned area, denoted by the black color in our graph. So, for this purpose, we created 3 different simulation scenarios with varying moisture levels to help us understand the potential impact of the real-time data. Our first setup consists of a grid with a uniform moisture content all around. The second setup has a a dense area in the middle of the grid with higher moisture. And we want to demonstrate here the effect of variability within a region. And the third scenario takes the same area of higher moisture and divides it into 3 different smaller areas. The overall area of the moisture content is the same, but here we have it spread more varyingly in the grid. And here we want to explore how these areas affect the spread. So here we have 2 comparisons. All 3 scenarios were run in different moisture conditions, one in lower moisture and one in normal moisture. And as we can see, the left one in the lower moisture comparison, we can see that in lower moisture conditions, wildfire spreads faster and overall burns larger areas. When we have normal moisture conditions, we can see a more gradual spread and the overall final burned area is lower. So these findings highlight the importance of having up-to-date moisture data for accurate fire spread predictions. Here, I'll just present the final percent burned area across all the scenarios. And as we can see, the scenario with the dense ellipse-shaped moisture, higher moisture area, performed the best in the normal situation where both of the different types of plants have the regular moisture, meaning they were not dry. And we see that it has an overall final percentage of around 67%. And all the low moisture conditions have an area, final area burned over 80%. So, as we can see, real-time moisture monitoring matters. Real-time data would provide a more precise input for our simulation, allowing us to do dynamic predictions on the fire spread. This can improve overall the resource allocations for firefighting, the targeted prevention strategies, such as controlled burns, and the rapid response to high-risk areas as conditions change. Finally, I will talk a little bit about our future work. The obvious next stage is to deploy the sensors and monitor in real time a selected area. These sensors will feed real-time data directly into the simulation model, enhancing our accuracy of wildfire spread prediction. This could lead to real-world testing in high-risk areas, providing more actionable insights for fire management. And finally, we want to build a decision support system which integrates the low-cost sensor network with a simulation platform so we can enable real-time fire spread predictions, creating a synergistic system that supports informed and timely decision-making. Here are just some of the references I use in my work. And I want to thank you for your attention and your interest in our work. I'm glad to answer any question.
Thanks for being overly on time. Very good. Now, I'll ask the audience to have any question. If not, I have 3 quick questions after the audience. The audience has the priority. Someone? Okay. If not, I can ask you 3 quick questions. I'm sorry, I didn't understand. How do you measure plant moisture? What kind of sensors are you using? It was not mentioned.
Oh, I told it in the beginning. we are using the sensor that was presenting in the previous session of Mr. Polymenakos, the sensor that used to measure the moisture in the olive tree for Xylella.
Okay, you should mention that. This is very important. That measures plant moisture. Okay, that's
Yes.
great. And do you consider also the difference among the plant species on the flammability? For example, a pine tree is different in flammability than other evergreen or broadleaf species, I mean annual species.
Yes, for this simulation,
yes.
No, we just took it. We just considered the plant moisture, and we set everything else in a baseline.
Okay.
I didn't mention it, but the simulation model is based on Mr. Alexandridis' cellular automata model.
Okay. Thank you. And the last question is, did you contact the civil protection for any collaboration? Your data can be tremendously valuable to these people for prevention. Do you have any collaboration? Do they know your work? Let me put it in plain terms.
For this project, no, but our department, our laboratory in the university has made projects with civil protections on other systems. So we're planning to collaborate when first we need to have real data, actual real data. We need to deploy the sensors.
Grace, make sure you do it as soon as possible. These people need you, and you'll save them. So thanks again. Thank you very much for everything. Good luck to the continuation of this work. Looks like a pretty good work. Thank you. So far you're doing very well on time, and I thank all the previous lecturers. Now, the next one will be an oral one by Mr. Marios Vasiliou from the University of Thessaly in Greece. And is Marios here? Yeah. He's on the way, and he will talk about green dried fruits and application, which is a dynamic disinfection modeling and application within dried currents commodity warehouse. So if we can find Mr. Marios Vasiliou. Hello.
Thank you very much.
You're welcome.
Perfect. My name is Marios Vasiliou. I'm a postdoc researcher at the University of Thessaly. And today we'll talk about the Green Dried Fruits app involving dynamic disinfestation modeling and application within dried currents commodity warehouse. Today we'll see a brief introduction, the methodology, the sensor app prototype that we developed, and some results and conclusions. Dried fruits holds a significant importance in the global food market, and the past year there was a total worldwide production over 3.1 million metric tons. Traditional disinfestation methods of dried fruits primarily rely on chemical treatments. These treatments can result in residual pesticides on dried fruits and can pose risks to consumers. On the other hand, it can also result in environmental impact, including potential contamination of soil and water sources. Alongside, there is an increased consumer demand for residue-free food, so this further enhances the necessity for developing more sustainable and eco-friendly alternatives. Now, in the light of this, physical treatments have emerged as an eco-friendly alternative that eliminate the need for chemical use. Thermal treatment, which is not something new, it's widely used, involves either high or low temperature in order to eradicate the pests. The effectiveness of thermal treatments relies on the type of pest, the moisture content of the fruit, and the uniformity of heat distribution, which is really important. However, chemical treatments are often preferred because they are more efficient, more cost-effective, and require less complex equipment and infrastructure. Nevertheless, there is need for non-chemical solutions, for example, for organic labels. To To this extent, in this research, we employ digital tools in order, and some modeling, in order to enhance these practices and be more efficient and more cost-effective. Now, in this research, we anticipate to monitor current warehouse status, to develop disinfestation protocols within thermal treatment, to establish a holistic disinfestation management mechanism, to model the different thermal treatments in terms of penetration variables, and develop an application tailored to warehouse actors in order to assist them to their procedures of disinfestation. In order to do that, we had a rigorous methodology. Initially, we did some preliminary simulations in order to investigate the airflow patterns and the patterns inside the warehouse. And later, we had the final modeling in terms of thermal penetration and thermal treatment. Now, the simulations inside the warehouse and exactly the chambers, both cold and heat chambers, are twofold. On the one end of the scale, we have the airflow simulations and heat flow simulation in order to investigate the airflow patterns and how the heat is distributed inside the chamber. And on the other hand of the spectrum, we have, on the other end of the spectrum, we have the heat transfer inside the pallet. Because in order to complete the disinfestation, we have to have a uniformity of the temperature in the whole pallet. On the left, we can see the heat chamber with some pallet configurations, while on the right, we can see the cold chamber with different pallet settings. On the left, we can see the heat flow inside the heat chamber, while on the right, we can see the airflow inside the cold chamber. This was important to be modeled and was able through computational fluid dynamic software in order to understand the airflow patterns and their impact on temperature variations. These are some results, but I will come back to that if there are any questions. Now, regarding the second part, which involves the uniformity of the temperature inside the pallets, we used spatial and temporal finite difference approximations into Fourier's law heat equations in order to model and further visualize the heat transfer inside the pallets. These are the pallets. For example, on the left 6 figures, we can see the temperature gradients inside the cold chamber. We can see that it's moving from the heat to cold. While on the right, we can see the same simulations, but in the heat chambers. However, in order to incorporate these simulations into our application, we would need high computational power. That's why we changed our modeling. And now it is it's based on the Newton's law of cooling in order to determine the duration required for the pallet temperature to reach the target temperatures. This involves the initial temperature of the pallet, the initial temperature of the chamber, the target temperature of the chamber, the specific heat capacity of the fruit pallet, and the thermal conductivity of the packaging material. However, in order to increase the accuracy of our models, we incorporated empirical data into the decay coefficient L, as you can see on the equation. In order now to calculate the L, the decay coefficient, we had to calculate the heat transfer coefficient H. And this was feasible through the installment of sensors on the pallet. This is the pallet, and the stars are the placements of the sensors in order to draw the data and calculate the coefficients. So having the initial temperature, the target temperature, the time, and the places of the data of the sensors, we can calculate the coefficients. As you can see on the left, this is the final equation, the final function that we're using in order to estimate the thermal penetration time. And on the figure on the left, it is a graph, an example with an initial temperature of about 20 degrees and target temperature of about 9 degrees. This is visualized with a frequency of 0.5 degrees Celsius and an offset of about 0.1 degree. This is important to be modeled this way with this frequency because the thermal penetration data have to be correlated with the thermal treatment data, as you can see in this slide. This is an example of the insect Oryzophilus cenamesis mortality rates. On the left, you can see the real data, the pragmatic data that we performed in the warehouse. And on the right, you can see some predictions, intermediate predictions based on this data. For example, at the top right, it is a 3D graph. The color scale represents the mortality rates, with yellow the 100% mortality. The vertical scale represents the exposure time in hours, while the horizontal scale is the temperature in degrees Celsius. Now, having on the one hand the thermal penetration variable, and on the other hand the thermal treatment estimation, we can calculate the total time for disinfestation. Moving forward, having this data, we built a system. As you can see, this is a system overview. We have sensors and a local server on the warehouse, which sends data to our server, to a cloud hosting. In the server, there are all the calculations, and of course, we have the final user who requests the data from the server. Now, this application is able to estimate the thermal treatment disinfestation time. It can monitor the warehouse status. It can provide information for all disinfestation procedures, and is able to record temperature and humidity in real time. This application is further augmented with a personal assistant. This was done because we needed to facilitate the digitalization process and assist the actors in the warehouse to their procedures. So we used generative artificial intelligence as an interactive chatbot for the users, which is able to respond to any question interaction through a chat. It has a user-friendly interface, and most importantly, it can access all the information of the database. This is important because if, for example, the user want to know the disinfestation time remaining for the pallet with ID 5, for example, it can ask the personal assistant with natural language and not have to read through the page. So it is easier, the whole process can be facilitated. Of course, this leads to enhanced data-driven decision support. To conclude, I will mention only some limitations because of the time. The ambient temperature might not be perfectly constant due to factors such as door openings in the refrigerator. However, this is mitigated through the empirical data that we already incorporated. Furthermore, the calculations are based on minor offsets, which is also mitigated using the iteration process of the modeling. And last but not least, there is a requirement of internet connectivity in order for this application to work, and the actors have to have a low level of familiarization with the application in order to be used. Thank you very much for your attention. I'm willing to engage any discussion.
Thank you, Marius. Very interesting, practical work. And is this available quotes, commercially, people can use this application? Or
This
it will become
This
soon?
is intended for the actors in a warehouse, in dreadful warehouse, and it is already used there. This is not for general public use.
Not yet.
We have it is online now. We have online through a website. We have also an application in the Play Store. However, it is used only by the actors in the warehouse. It's not meant to be used for the general public.
And I think the limitation you mentioned, it requires internet connectivity. That's not a limitation nowadays. It costs you very, very little to have that.
Well, in some places,
yes,
there is. Also, in some parts of the chambers, if the worker goes inside the chamber and tries to use the application, there may be some minor interferences and some delays because of the internet connectivity.
Transmission problems. Okay,
exactly.
Thanks a lot. The audience, any question, please? Any comments? If not, thanks again. And
Thank you very much.
Keep improving that one. Make it commercial.
Thank you.
All right. Bye-bye. So, we got the next one. I know the gentleman. I won't say his name. Dr. Christopher Brewster. He's going to present planetary health and digital agriculture, rethinking technological innovation. That will be a very philosophical perspective. Go ahead.
This will be philosophical. Thank you for... I'm an old hand in this world of digital agriculture. I've been playing with this for quite a while. But as time goes by, I come to rethink exactly what we're doing. And it's interesting, there have been talks here that have slightly touched on issues to do with the environmental impact of agriculture. But generally there has been an avoidance of that discussion. So we live in critical times. We are suffering from climate breakdown and biodiversity collapse. A report just produced by the World Wildlife Fund just a few days ago talks about a 73% decline in wild animals globally. There is plenty of evidence that in Europe we've had an over 75% collapse of insect populations. Now remember, agriculture is dependent on insect populations. It both destroys them and depends on them for pollination. More than half of our agricultural products are dependent on pollination. We are breaking the planetary boundaries in multiple dimensions. Out of the 9 identified planetary boundaries, we have already broken 6 of them. So there is a sort of tsunami of issues that the food and agriculture sector is intimately related to, both climate breakdown and biodiversity collapse. Industrial agriculture is the culprit. If you look at the global food system, it's responsible for more than 27% of greenhouse gas emissions. If you take the food system as a whole, it's more than a third. It's responsible for 70% of fresh water extraction, and fresh water is becoming an issue, strangely enough, not just in Greece, where we might expect it, but in countries like the Netherlands, where it's completely unexpected to have freshwater issues. It's a main threat to 86% of species which are at risk of extinction. Agriculture drives 90% of tropical deforestation, and 82% of agricultural lands are used for either grazing or producing feedstocks for livestock. I was just talking to one of our attendees at the dinner yesterday about the transformation in Greek livestock agriculture from extensive farming to intensive farming, which then means that somewhere somebody has to grow grass to feed those sheep and goats that are now enclosed in concentrated feedlots. It's also the victim of all this. Agriculture across the world, and you are very aware of it in Greece, is suffering from these effects. We've seen the floods repeatedly. We've seen the droughts repeatedly. and it's getting worse. Think of the temperatures that we encountered in Greece this past summer. Unprecedented temperatures, not just the individual number over 40 degrees, we've had that before in Greece many times, but the extents, days and days and days at over 40 degrees. Unbelievable. And with a very, very negative projection over coming years, right? So there is an agri-tech imaginary. I use this word imaginary because it comes from cultural studies, from literature and that sort of thing, about the imagination that we attach to a particular idea or, in this case, a set of technologies. There are academic papers, policy documents, funding strategies, funded projects, and the mushrooming startup sector, of which some of you are connected to, all promise that digital agriculture and smart farming will reduce inputs for the same output, will reduce labor costs through automation, and will provide separate income streams by exploiting data. It reflects a deeply held cultural belief that more technology is better and will solve the problems of agri-food. It's a very techno-utopian perspective, and it's historically untrue. You can go back to the whole history of modern agriculture, starting with the exploitation of guano in the 1830s, through the development of pesticides in the mid and 19th century, the real growth after the discovery of the Haber-Bosch process, the commercialization of seeds. So instead of reusing past seeds, it became a commercial input. So there's always been this growth of various kinds of inputs into the agriculture sector. The consequence has been twofold. One has been more damage to the environment and lower profits for farmers themselves. So while there are sort of golden ages, if you look in the past 200 years for agriculture, all that has slowly, slowly disappeared more and more over time. And unfortunately, there is little evidence to show that all this world of innovation that I am deeply embedded in, I'm partly responsible for, is actually benefiting either the farmer or the environment. The real issue is by what criteria new technologies are evaluated and who benefits. I'm not going to go into the who benefits. It's a complicated thing which takes us too far away from the information technology aspect here. But I will discuss a little bit about the evaluation. There are current limits to evaluating agri-tech. A lot of the academic papers arguing for the benefits of agri-tech. A good example is Papadopoulos 2024, which is a recent publication. There's tons of it. I mean, there's lots and lots. But the problem is, what are the criteria? They're always relative and not absolute. It's always, this is better than what we had yesterday or what we had recently. Data is often self-reported, and I can talk about that because I'm involved in some of these projects and I really don't trust the data. Data is limited to one plot or one farm. And there's a kind of problematic chain of reasoning which is not always well evidenced. So, less diesel equals less greenhouse gases, so this is better for the environment, so it's better for biodiversity. There's no actual measurement of the real greenhouse gas emissions on the farm or the real impact on biodiversity. It's always model-based or indirect. So there's a real issue there about the quality of the data that we are basing our comparative criteria on. And I can point you to a project like Quantifarm, which I co-wrote. If you want to look at this tool, it actually gives you lots of comparisons about various digital technologies. It's sort of mid-process of the work, so don't consider it a complete data set, but it's working on 33 test cases around Europe. Each time we have farms with a digital technology and without, and we're collecting a whole collection of 80 plus different data parameters on the social, economic, and environmental impacts of these digital technologies. What I want to argue for is a planetary health analytical framework. I want to say we have to zoom out and have a much more systems approach to understanding the role of technology, the role of innovation at all in agriculture, so that we can make more informed, more thoughtful judgments as to which direction our research, our technology development, or our various types of innovations should go. Because we tend to think, and I mean, representing here TNO, I can say this is very much part of the culture, and you will be familiar with it with a lot of institutions. Innovation is, we come up with a gizmo, a nice new drone, a nice new something or another, and we expect that solution to be sold 1 million times and to be very successful. I'll be quick now to finish.
Don't worry, I can give you 2 extra minutes.
So a planetary health perspective recognizes the interdependence between human health and flourishing natural systems. It emphasizes complex interdependencies. It's inspired by the idea of planetary health, which has a long history but has been kind of relaunched in the last 10 years by the Lancet Planetary Health Initiative. And it's also inspired my ideas here by the greenhouse gas emissions assessment, which involves looking at the scope 1, scope 2, scope 3 areas of emissions, emissions that you make yourself, emissions that your immediate suppliers do, and emissions that are the result of the whole supply chain. So in each case, I propose a series of questions to ask, and these could eventually become a more sophisticated assessment or evaluation approach. Or possibly not, because there's another discussion there about just whether this constant desire to evaluate is really the right approach to achieve systemic change. So here we could consider about, on the farm, does a digital agricultural technology help the farmer? Does it actually help the farmer? And by what criteria? Is it just financially beneficial? So I've heard reports of farmers in Belgium, for example, who do not want dairy robots because they say it will reduce their contact with their cows, and they like their contact with their cows. Does it really help the farmer? Mm-hmm. Does the digital agricultural technology support the non-human inhabitants of the farm? All the birds, bees, insects, all those others, which are very much part of that ecosystem and are very much part of what supports the agricultural system as a whole. Does the technology capture the right data on the farm? The technology is often measuring something, but is it the right thing? Is it what we really need to be measuring? Does it increase or decrease crop diversity? Many of you will be familiar with the fact that we've lost crop diversity at an enormous scale in the last 100, 150 years. We grow far fewer apples. We grow far fewer varieties of aubergines or whatever. Pick any plant, even olives. We grow far fewer types of olives today than we did 50 or 100 years ago. You might say that's great. But think of the story of the banana, and there are many other agricultural products like that, that then suddenly collapse because there's a particular virus that attacks, and there's no crop diversity. Is the technology de-skilling or reskilling farmers or farmers? Are we making our farmers more stupid by the technology because we offer a solution that enables all the decisions to be made by the system rather than the farmer? Is the technology further distancing farmers and thus whole societies from plants, animals, and nature as a whole? We could also look at it at the landscape level, the valley, the community, the wider geographical area. Within the landscape, does the technology increase biodiversity? Does the adoption of the technology lead inevitably to greater consolidation of farms? We know that this is a problem across Europe and across the world, the reduction of the total number of farms. As farms get bigger, they tend to have more monoculture and therefore be more damaging for the environment. Does the automation and other efficiencies on the farm mean even fewer jobs in the rural area? I mean, do we want everybody to live in the cities and nobody in the country? I mean, all these EU initiatives to support the rural areas, what are we doing? I mean, are we actually supporting the farmers to carry on farming? I asked this question. How many of you would recommend your teenage child to become a farmer today? for the planet, in what ways do the increase in use of sensors, drones, robots, autonomous vehicles, and all that actually increase the overall energy consumption or help achieve carbon zero? Think of the revision of projected carbon emissions for the big tech companies. So Microsoft, Amazon, Apple have all said where we had planned to achieve net zero, which we can argue about by 2030, they're now saying it's impossible. Why? Because of large language models and the use of AI. We can't do it. Everything is blown out of proportion. Will the increased use of technology further increase social inequality, social stratification, and disenfranchisement? And that goes into the whole who benefits issue. And does the greater uptake of technology increase food security, especially food resilience? And does the dependence on these technologies create new vulnerabilities? I think we have to look at that. So I finish off. I argue for a more systemic, integrative, and planetary scale perspective on the growing adoption and continuous promotion of digital agricultural technology. I'm arguing for a systems perspective, and we need a more nuanced assessment of capabilities for innovation in general. And here I reference Ivan Illich's threshold of counterproductivity. Questions? I leave you with a quote from Upton Sinclair to forgive your insistence on more technology. It's difficult to get a man to understand something when his salary depends upon his not understanding it.
Well, thank you very much, Dr. Webster. I think we shouldn't ask questions. You ask so many and very nice questions. Also, please send this presentation to the EU DG Agri officers to read it and start questioning, start rethinking. It was very nice, and really, we all have to do a lot of rethinking. You pose the questions. All these questions are more or less focusing on a global issue, a holistic approach. No more, I mean, I can agree with you even more with the insects. They are not only pollinators, but they're the future food of humans. So too many aspects of this. Please, if you have any question.
If I can say something.
Yes, of course you can.
Just about pollinators, I mean, the digital technologies are not very beneficial, especially for pollinators. I mean, most of the practices are much more labor intensive, and this is a strong barrier, especially for the farmers that if they want to adopt. For example, just an example about in France, because we are working for pollinators and new restoration measures. I mean, the biggest problem it was the labor, and not the labor because it changed the volume of the work. It was that it's changing their work calendar. So they were resistant, not because they didn't have to work more, they just have to work different days from the days that they were accustomed to work. And that is a very strong barrier, especially for the French farmers. So.
Yes, that's totally, but I think the most critical question he asked is, would you convince your son to become a farmer? I'm trying to do it with my two little nephews. I convinced one, but the other is, no, I will do business and economics. I want to make money, he said. So
That's the biggest problem in EU level.
Not in EU, believe me, it's everywhere. Labor is the most important issue in agriculture. Next person will be Mr. Stelios Zimeras. Is he around? From the University of Aegean. Stelios Zimeras, segmentation models using active contours for environmental disease images. Welcome. So you will represent Samos in this lecture, right?
Yes, yes.
Yeah, go ahead. I will.
All right, so first of all, I want to welcome you in our island. I hope to enjoy your stay here. We have a very good weather these days. This is good for the activities. My name is Stelios Zimeras. I'm from the Department of Statistics and Actuarial and Financial Mathematics, University of Aegean, here. At the same time, I'm the head of the department. So if somebody wants to have some questions after, I will be very glad to answer them. And the work that I will present is a very simple work in this stage, but we have done some other improvements, and hopefully I will expect to present in some other conference or in a papers. The idea behind this work is really how we can be beneficial from images who has homogeneous regions, really regions that they have the same characteristics. In this case, here that we present a very simple image that we have, as we said here, disease images, environmental, is one image from a very big, some image from a very big image from COVID, we will see after. And that we will try to do is to recognize the regions that they have really some interest. For that reason, we use the segmentation models or analysis that I will present. So, to the point now, the main idea behind all this kind of techniques are based on the spatial temporal models that they use same time spatial connectivity between pixels, so they recognize the same region, and at the same time how they move in the time. Here we don't have different times, we have only one particular image, but we have done the same work in a time, for example, 10 images in different time periods. The other thing that we need to introduce is the segmentation methods. Is the methods that is essential process from investigating image edges. The key word here is the edges, and we'll see how we will benefit from that. So we have the homogeneity based on some common features that I said before, and the segmentation really, it's the general properties from the segmentation. The main idea, as you can see, is if we have an image, we need to have many different regions. We have the same characteristics, that they are not combined together. So, and the idea behind this work is how, because we have edges that they are not straight, we have edges with very complicated shapes. In this case, the idea behind this work is to use the active contours models or the snake models. They have the different name. And the idea behind this work is really, as you see in this feature here, we try to find the edges of a region that is not regular, is irregular. I will not stay really in the mathematical aspects because it's a little bit, some of them are complicated, but some of the general mathematics is, for example, we can see that really we have energies, as we see in a graph, from where the edge have different energies, so you can have the shape. The two energies, the internal and the external. The internal is the contour shape, and the external is the energy depending on the characteristics of the image. And for example, we can see the different, for this particular example, that we start from a region, and after some iterations, we find the the edge of a particular region. The general form of the Arctic corridor is that, all right? Really, we have the internal, the image, and the external, and this is the three energies. The internal is referring to the curve or elasticity that you can see. The image energy refers to the brightness, the colors of the image, and the external energy referring to the characteristics of the image, how is the, if we have bigger or smaller regions. And that really we try to minimize in general. This form, I will not stay here really, and here is the result because I think this is the most interesting. So here we have a very small image where the black is the disease from a region with COVID, and after 200 iterations, we can see that we have the particular result. And of course, we can see here, I don't know, it's somewhere that, all right. We can see, for example, the edges. We have really, in this part here, we have two edges, the inside and the outside. And that's the problem that we need to solve. And that, this example is given here a little bit much more recognized based on the region growing technique. Is a technique really that we try to do is to fill with the color with the image. And for example, if we use a blurring box process, which is a region where we calculate, for example, the sharpness or the clearness of the image, in different, as you can see here, again, I think it's that, in different variations, you can see that we have different results. As we increase the variation of the blurring process, the results are getting much more worse. The problem is how we can fight the problem. We have found some ideas, but we need to implement, have more examples. How we can find this threshold really? Yes, I finished. Really in automatic way, no with trial and error. Here is trial and error. We use different values and we have the result, and that's it. We see the result. That's a little bit more complicated. And the final is if we combine the blending process with the Gaussian noise, we can see the result here, the result. And of course, if we increase the noise, the image is getting much more worse. That's it. Thank you very much.
You were perfect. 8 minutes, 44 seconds.
If there is any question, I will be very happy to answer.
Anybody knows more mathematics than Pythagoras, please ask questions. Yeah, it's, thank you very much.
All right, thank you.
We do enjoy staying in Samos.
Yes.
And we will enjoy it more tomorrow or today.
Yes,
now,
yes,
let me briefly, kindly ask the audience, the next session should start in 6 minutes. It's a coffee break. It will start in 15 minutes. In 1 o'clock, okay. Thanks to the generosity by Dr. Blonzos, we will take a little extension. So 1 o'clock, let's everybody be on time in this room. If necessary, bring your coffee if you need a second one. Thank you all very much, and let's enjoy a coffee break.
To start this session. This is a special session consisting of presentations related to a specific Horizon project. The acronym of it is NATAE. NATAE project is focusing on assessing and promoting agroecological practices in Northern African countries via the deployment and development of living clubs in Egypt, Tunisia, Morocco, Algeria, and Mauritania. So the first presenter is Mr. Vasilis Angelopoulos, who will talk about assessing consumer awareness and willingness to pay for agroecological products in Egypt, an explanatory study. So Vasilis, you can start.
Okay. I hope you hear me. Okay. Okay, my name is Vasilis Angelopoulos, and the topic that I will present to you is assessing consumer awareness and willingness to pay for agroecological products in Egypt, which was conducted in the context of the NATAE project. Some introductory points. Implementing agroecological practices can increase biodiversity by 30% and reduce pesticide use by 50%. And in addition, researchers recommend agroecology as a solution for food security and environmental problems. However, implementing agroecological practices face some obstacles. The most critical is a lack of consumer awareness and a decrease in willingness to pay for innovative products, especially in developing countries. However, there are no complete studies conducted on consumer behavior in North Africa regarding agroecology. And the studies focus mainly on precision technology, soil management, and organic production. Therefore, the aim of the study is to fill the literature gap by providing comprehensive data on the level of consumer awareness, especially in Egypt, toward agroecological products, and to identify and understand different socioeconomic aspects that affect consumers' purchasing behavior toward these innovative agroecological products. This is the research methodology. And regarding the questionnaire design, the models that were used were the theory of plant behavior, the responsible environmental behavior model, and the model of the stimulus organism response. The questionnaires that were selected from Egypt were 446 in the period of April 1st to May 15th of 2024, either online or through paper-based, in a paper-based form. For the data analysis was used the SPSS software packets, and the techniques used were descriptive analysis, principal component analysis, linear regression, and ANOVA. And for each one, there were some tests that performed in order to check some assumptions. Specifically for the questionnaire, it consisted of 45 questions and was divided into 5 sections, which were the demographic and socioeconomic characteristics, the environmental issues, the environmental attitudes, agroecological practices, and the willingness to pay. And for the 3 middle ones, the answers were based on a 5 Likert scale. Now, regarding the results of the descriptive analysis, as we see, most respondents were male. In addition, most respondents belong to the age group 20 to 24, and most were employed with a percent of 63.9%. Additionally, most were living in an urban area with a percent of 76.7%. Their educational level of most respondents were bachelor with a percent of 75.1%, and most respondents considered their average monthly income satisfactory. Now, regarding the components from the PCA, those that resulted and were kept based on the criteria that the eigenvalue was greater than 1 were those 9, and these 9 factors explained 62% of variance in the Egypt's data. Then was performed a multiple linear regression analysis for each of those 9 factors as dependent variables, and as independent variables were used the socioeconomic and demographic characteristics. And those ones that kept and had statistical significance were the consumer perspectives on the environment's future, consumer awareness of farming practices, consumer knowledge about agroecological practices, consumer awareness about environmental problems, and lastly, consumer beliefs and impact on the environment. Now, for the results of the ANOVA, were kept 2 components based on some tests that were performed and on some assumptions that we made and had to be met. And the first component was the consumer perspectives on environment future, where we see that those with a higher educational background had also higher environmental awareness. The second component that was kept was consumer awareness of farming practices, where we see those that belong to the age groups of 20 to 24, 25 to 29, and 34 to 39, as well as those living in rural areas, had a higher awareness of farming practices. Lastly, for the results of the willingness to pay for cereal products from agroecology, we see that the model had statistical significance, and down there we see the linear regression equation. To conclude, we can say that different factors resulted from the principal component analysis proved to have a statistical significance on consumer behavior toward agroecological practices, and the factors that reflect environmental concern proved to be also significant toward purchasing these products. And the last point, in this study, we found significance in the willingness to pay for cereal products from agroecology in Egypt, indicating a rise in willingness to pay among participants with a lower work status, as well as the willingness to pay increases as average monthly income and the number of adults in households increase. Thank you for your attention.
Thank you very much, Vasilis. Are there any questions? Yes, Samir.
First, thank you for the presentation, for the study. I think too few studies, or maybe nothing, as you said there. Just very specific comment in the last slide. There is an awareness of consumer on agroecology and for cereals. You know that Egypt is, as you know, almost all the cereal they consume from imports. From the first important country in cereal. So awareness in agroecology with an imported product, if it is produced locally, okay, but this is imported. So it's this, do you find this in accordance with literature? With is this expected for you, this result?
Well, the respondents, I had to choose, let's say, to answer for different categories of food products. So we the one product that was found to have statistical significance was the cereal products. So that is why we presented this one. But yes, this is a good point you make.
Can I make another more general point? It doesn't, I mean, it affects the fundamental assumption of this willingness to pay for agroecology, which applies equally to organic and to various other characteristics of food. This is not how the food system has worked for the last 7,500 years, so definitely after the Second World War. We have had huge marketing campaigns from various sources, mostly major food companies, to persuade consumer behavior in a particular direction, very successfully. It's not by kind of investigating whether consumers are prepared to pay. Consumers will pay anything you tell them to pay if you spend enough on marketing. So there's the issue for agroecology, for organic, for all those alternative models is really to do with who is prepared to put in the effort, the push to change consumer behavior. Consumer behavior will change, has changed repeatedly, as anybody of a certain age who remembers food systems from earlier will confirm. Just a passing comment.
Yeah, yes. I mean, on the one hand, some marketing campaigns can let's say, be conducive to a change in their willingness to pay, but also we can consider also more systemic issues that we should also take into account.
Okay, thank you very much, Vasilis. And we are moving to the next presenter, who is online. The title of the next presentation is Agroecological Perspectives in North African National Public Policies, a transversal analysis of trends, strengths, and weaknesses, and the presenter is Mrs. Rita Jackal.
Hello, everyone. Can you hear me?
Hello, Rita.
Hello, George. Hello, everyone. It is a pleasure to be with you today. Even if over a screen, I'm sorry I was not able to attend the conference in person. I am Rita Jalk. I'm the project manager for NATAE, based at the International Agronomic Institute in Montpellier, France. And I also have research duties in the project, such as value chain analysis and our topic today, which is the public policy analysis. So this work I'm presenting today is based on a big deliverable under the project that was submitted back in May. It consists of an overview of public policies in 5 North African countries, including Algeria, Egypt, Mauritania, Morocco, and Tunisia. It is a true collaborative work with our colleagues, and many people participated in this deliverable, over 15 people from 7 of the 23 partners in the project. This deliverable is public, and you can find it on the link on this displayed on the screen. So the task mainly, the objective of it was to provide this overview of cross-sectoral policies in North Africa, mainly to identify and assess their impact on agroecology. Do they provide a lever, or do they provide barriers for its transition and their adoption? What are gaps or trends or common observations that we can identify to help forward construction of policy proposals in the future steps of the project? The structure of the task was the coordination team was based here in France at the CIAM under the supervision of 2 recruited experts and myself as the postdoc researcher responsible for coordination. And there was a nominated partner per country to coordinate the task mainly in every country, whereas we also recruited certain experts such as in Egypt. So after the nomination of the national coordinators, which was the first step, we have tried to standardize the data collection and the analysis of the policy documents. We mainly asked for 5 policy documents to be analyzed per country based on a proposed grid. This grid asked specific questions on the orientation of the policies, what are their objectives, if agroecology is mentioned, if yes, how, under what orientations, which actors are involved, by which means, the funding, and so on. Other than that, we have proposed also to the partners to conduct an interview guide with different kinds of stakeholders, not only farmers, but also including academic institutes, research centers, civil society, NGOs, and including government representatives, of course. We asked them questions on their knowledge of agroecology. How do they understand it? Do they see it as a need? Does it come with risks? What are their benefits? And so on. And to try and understand what is the potential of their adoption or not. And finally, we have collected all information in a unified outline for the overall deliverable. We discussed, of course, results in several series of workshops. And at the end, we received 1 national report per country, which was supplemented by further information on different sectors. It's not part of the abstract or my work presentation today, but it's interesting to know that other sectoral policies were also included, such as trade, finance, and so on. And so this is how we arrived to construct the transversal analysis. The deliverable itself provides a very in-depth description of the context and background from different aspects, such as social, economic, environmental. The focus today is on the listing and the analysis of the policy documents, which, when we tried to categorize them, what kind of observations and contradictions we were able to identify. I will also give a quick overview on the perception of the stakeholders, and the deliverable finally dedicated 1 chapter for every national report we received. So to start with the common identified issues, what we noticed is that food security is a major concern in North Africa, which comes under a context of let's say, climate instability, risks of desertification, limited access to resources, resource management, and so on. And so we have noticed that a lot of the priorities in the policy call for an increase in the production and productivity and export. So there is a true effort to try and decrease dependence on food and imports. But at the same time, we have seen notions of environmental sustainability, management of resources, and so on. So there is a notion of environmental concerns, which normally revolves around water-related issues in North Africa. Not only, it could also include topics such as soil biodiversity, land, and so on, forests. But even if there are some repetitive terms or common terms that we were able to identify in the different countries, such as preservation, rehabilitation, and so on, we have identified very strong paradoxes, which even if the terms are included in the policy documents, the orientation of the documents themselves are still geared toward a growth model, an agricultural growth model based on intensification. These are concrete examples from each of the countries. I will not go into a lot of details, but interesting observations were received, for example, from Egypt. Egypt calls for, encourages the use of drip irrigation, not only for the water reduction objectives, but in fact, to be able to cultivate more land, to produce more. And so there are several big projects based on the reclamation of agricultural land in the desert. So we see this reduction in the resource is not only for sustainability or management of the resource, but in fact to be able to produce more. Similarly, in Mauritania, there was a call for introduction of high growth potential cultivations in terms of the varieties being introduced. And Mauritania is one of the countries that very interestingly calls for a shift from subsistence agriculture, which is very common in Mauritania for self-consumption on small family farms. And so there is this logic of shifting from subsistence agriculture towards more competitive and market-oriented production. And we see very similar trends in most of the countries, basically. Other than that, we see that the different themes introduced in policy documents, such as environmental, biodiversity, water, natural resources, are repetitive. They enter in different policy documents that are managed by different governmental bodies. And what remains unclear is how these communicate between each other. Are they in synergy or not? Other unclarities include, for example, how a specific strategy is translated into direct action plans or direct programs. So this is also another observation. Whereas we see that, yes, the understanding of terms, even though they are similar, they take different trajectories in different countries. We also saw that the notion of agroecology by itself, it is rarely really mentioned as is in the policy documents, but it has been introduced in certain cases. But what is certain is that it has been introduced with efforts with international collaboration and cooperation. Whether it is in the formulation of the policy documents themselves, such as in Egypt, or in programs that come in fundings received from international communities. So agroecology by itself has not been intrinsic, let's say, to North Africa. And what is certain is that research today is still a big gap, meaning what is agroecology in North Africa? What is place-based research or research coming from the localities themselves on agroecological practices is still in its very early stages. And so this causes a problem because there is no skills that are specialized in agroecology in North Africa to this day. But we have seen, interestingly, some nuclei that exist, for example, specifically in NGOs or specific academic institutes. But for now, it is still very fragmented. And finally, just a word on the perception of agroecology. What we saw that its understanding is diverse between the different stakeholders normally. We saw that farmers do not have a very advanced knowledge on what is agroecology, but interestingly, they do apply agroecological practices, but it comes out of necessity and not out of awareness, let's say. There's, of course, lack of resources at their scale, but they have a certain fear for the risks that come by changing their ways. For researchers, normally, yes, they have a knowledge on agroecology, but it is still not a very high priority because the funding is quite limited due to agroecology not being a very high priority in policies or in public authorities. So the budget is limited, the research is still fragmented, and what is greatly missing is place-based, specialized research from localities themselves. NGOs and professional organizations are very, very interesting stakeholders because they are in direct collaboration with international cooperation efforts, which means that they are aware of what is agroecology, and they are positioned in a way to demonstrate findings for farmers. But still, again, what is needed is this science backup for their efforts. And finally, for public authorities, we saw that agroecology is not really on their priority list because for many reasons. I mean, there are the urgent challenges that they have to face, mainly food security, and they are still focused on how can we produce more, how can we reduce our dependency on food imports. So they are not paying that much attention to agroecology, and they don't really understand what costs are attributed to agroecology. So as a conclusion, we see that the main barriers are very clear at the moment. There are very urgent challenges being faced, and they are the priority, mainly food security. There's weak access to technical and adapted scientific knowledge, which is a gap. And finally, what are the risks that come with adopting agroecology? And I mean, they have to communicate together, the research, the NGOs, and demonstrations for farmers to be able to build some sort of advocacy to affect public authority opinions, to shift the support more and to increase the support more. And I thank you very much for your attention.
Thank you. Okay. Before proceeding to questions, I want to make some clarification comments on both presentations. This project is a pioneer project because we are trying to introduce and promote agroecology on a very, very difficult place on Earth. And you have realized that the findings of both presentations are quite contradictory. We have on a policy or a national level, let's say a more realistic approach that there is no a clear approach, a clear view about what agroecology is. But on the consumer level, in various cases in Northern African countries, we have a different perspective. The consumers declare that they are aware about agroecology. We know, the social scientists, we know that we cannot change the respondents' point of view, but we have to verify the validity of their view. So at this stage, we are able to have all these empirical studies as a reference point for future works, because all the deliverables will be reference points for future work, because this is the first time we are developing such works in Northern African countries. So I really, really understand and appreciate your skepticism about the results that we are presenting, but this is the way that we normally do things, and by all means, we will try during the last phase of this project to better inform all users, all members of specific value chains about what agroecology is and which are the means of better apply the principles of agroecology and utilize the benefits derived from such applications. Okay, thank you very much. So are there any other questions for Rita? Yes, Christopher. Just a moment of the mic.
I'm very interested in this project's focus on agroecology, particularly as there is a confusion, or let's say a game of marketing between different terms. I treat agroecology as a generic label, organic agriculture as being one instance.
It's something different.
I know, but it's still related.
Yes,
Now we've come across the term in the last 5 years or more of regenerative agriculture, which has come in as with a big push from a lot of big companies. I'm wondering whether you see the label regenerative as being present in the areas that you're working on there in North Africa. Has that come in as a label that is being promoted by outside parties?
Rita, would you like to answer this? Because you have studied all the related policies already implemented in all these countries.
Yes, thank you. That's an interesting question. In fact, the term has not appeared anywhere, no. But it is interesting to note that the project is really touching on a section of research which has not done before. Really, everything we are finding for the first time. In terms of how, let's say, integrated agroecology or not, we have only small evidence. The general rule is still far away from any term that is related to agroecology, whether organic, whether regenerative, or so on. But interestingly, in certain countries, specifically in Tunisia, they are one of the most advanced countries in North Africa in focusing on organic productions. And not only productions, but also at the value chain level and the consumer levels. Consumers are very, very much aware what is organic. There is certification that exists, and the system quite, let's say, goes on in a full circle, meaning there are, I don't want to say there are no gaps, there are always gaps, but the system is well established and well advanced. But what comes more in a bigger concept, such as agroecology, this is where we go into really big questions that we still do not have a lot of insight on. And this is why the project is so interesting, because on one hand, as George said, there are insights or indications that consumers could be aware, but we are, for now, it doesn't show in the policy side. So there is this sort of gap that needs to be filling. For me, I would be more than happy to know that consumers are aware and they know that they should shift their consumption behaviors and trends towards more agroecological practices. So this is where marketing, I think, can play a very nice role of creating this bridge between those two. I hope I answered your question.
Thank you very much, Rita. And are there any other questions or comments? Okay, we are now proceeding to the next presentation, entitled Understanding the Impact of Agroecology on Consumer Behavior, a Systematic Review. It's going to be presented by Dr. Christina Klisiari. So, Christina?
Yes. Hello, everyone. I'm Christina Klisiari. I'm a postdoc researcher at the Laboratory of Agricultural Economics and Consumer Behavior at the University of Thessaly. And today I will present to you the work entitled Understanding the Impact of Agroecology on Consumer Behavior, a Systematic Literature Review. Of course, it is under the principles of NATAE project. So, here are the main contents of my presentation. I will start with a brief introduction regarding agroecological practices. After that, I will talk about the main objectives and research question of the research that have led us to choose the appropriate methodology and the main selection criteria so as to have the main results and conclusions of our study. So, to start with the introduction, it is very important to define the term agroecology. And what is agroecology? Agroecology, according to FAO, is the science of applying ecological concepts and principles to manage interactions between both plants and animals, of course, humans, and the environment for food security and nutrition. For this reason, FAO has created 10 main agroecological elements, including diversity, synergies, efficiency, recycling, resilience, etc. We can describe this scheme, this procedure, as a circular procedure where farmers, which is the start of the value chain, are trying to produce with more eco-friendly practices so as to meet the ever-increasing needs of consumers who are more and more informed regarding agroecological practices and eco-friendly practices. Also, we have noticed that in recent years, we have the willingness of consumers to pay a premium price so as to obtain and to purchase agroecological products is higher. Here in this graph, there is a pyramid, the 5 stages pyramid, introduced by FAO as well, while the first stage of this pyramid is talking about the increasement of the efficiency of both industrial and conventional practices, while the last stage, the last level of this pyramid is talking about the expansion of all these agroecological practices into a greater scale. So we have noticed, talking about the most relevant literature, we have noticed that the current literature focuses more on environmental and production aspects rather than consumer-driven insights. Also, there is a huge gap in understanding how the way that agroecological practices influence consumer behavior and market dynamics. So, according to this, we have the main objectives of our study, which is to understand and identify the pattern of adopting agroecological practices according to consumers' personal characteristics. I mean their demographics or socioeconomic characteristics like age, gender, and their income, so as to examine the main impact of agroecological practices on their behavior. So we have concluded to 4 main research questions. The first 2 research questions are about the impact of the implementation of agroecological practices on both consumer awareness and their purchasing decisions. Of course, we have to identify the main, which are the main socioeconomic and geographical insights that play an important role in influencing consumer preferences for agroecological practices, for agroecological products, and of course, we can recommend to stakeholders what are the main implications for them, for both farmers and policymakers, so as to promote better, in a better way, sustainable products. We have used PRISMA guidelines with both databases from Scopus and Web of Science, and we have used the main keywords that we have used were consumer behavior, agroecology, sustainability, and agricultural products, of course. After database selection and the validation of both quality and content of the index of our papers, of course, we have removed duplicates, out of scope, non-English or non-available full-text papers, and we have concluded to 122 papers. Here in these graphs, first of all, you can see the main journals with the most relevant published papers in terms of both agroecology and consumer behavior, while in the second graph, you can see that among the main food categories linked to consumer behavior and agroecology, we have arable crops, vegetables and fruits, milk and dairy products, meat, and of course, the biggest category is referring to sustainable and organic products. Now, let's move forward to the results. With the use of VOS Viewer, we have 4 main clusters referring to terms consumer behavior and agroecological practices. The first one is about consumer behavior and decision-making process. It is the blue-colored one, while the second cluster is referring to sustainability and environmental concern. Also, we have a separate cluster here talking about ethical consumption, while the last one is referring to health and environmental responsibility in consumer choices. Now, let's talk a little bit about the main factors influencing consumers regarding to the adoption, the purchasing of agroecological products. First of all, and the main factor according to these papers, is consumer awareness. Exposure to agroecological practices enhances more and more consumer awareness, but at the same time it varies depending on their demographic and socioeconomic characteristics. Secondly, we have the perception of quality. Most of the consumers believe that these kind of products are products of higher quality, but price is the main barrier for them. Willingness to pay a premium price for this kind of products is influenced by their health and environmental benefits, with a strong influence on targeting marketing. Of course, as I've said to you before, age, income, and other demographic characteristics play a crucial role in influencing this kind of decision-making process. We have some barriers to adopt or to purchase this kind of products. The main barrier is that the high cost, the price of this kind of products, while the second one is that we have a lack of sufficient marketing and educational strategies from policymakers and the other stakeholders. The main gaps that we have identified were that we have to focus more in separate geographical regions, like in peri-urban, urban, and rural regions. So to conclude, of course, agroecology has the potential to positively influence consumer behavior, but we have significant barriers to overcome. Targeted strategies and policies such as the support of regulations promoting sustainable and agroecological products are important so as to promote better sustainable consumption. For farmers, what we can advise them is to develop more affordable and accessible agroecological products. Yes, what we can say is that the agricultural sector must align more with consumer demands for ethical and sustainable products. Thank you.
Thank you very much. Any questions? Yes, Samir. Just a moment for the mic.
Thank you very much for a very clear and insightful presentation. With respect to barriers to adopt agroecological products, you mentioned the price, which
yes.
I agree, it's clear, because also we know we are in context of food inflation, so it's did you found other barriers and significant, for example, availability of these products in retailing? And, maybe it's not. And the other point is, do you think that the public procurement, for example, in school, in hospital, could be a driver for these products?
Yes. Thanks for your remark. No, I think that availability isn't a barrier because they correlate, most of the consumers correlate agroecological products with organic products or sustainable products. So most of them are aware of this kind of products. So no, this is not a barrier for them. The most significant barrier is the price, of course, and the lack of educational strategies so as to be more coherent and clear to them what agroecology and what agroecological practices are. Yes, educational strategies. Yeah. Not only for farmers, but for consumers as well.
Okay.
Yes, it's a good strategy. We could recommend this strategy, yes, to policymakers.
Thank you.
Thank you.
Yeah, I mean, this goes back to a previous comment I made. There's a kind of confusion here between different perceptions, both at the farmer level and at the consumer level, because we have these. I mean, think of whether you would promote agroecological or local products as being more, you know. I think there's without having a marketing campaign behind it, local is quite a positively seen product label, while agroecology, I would argue, might have a higher penetration among farmers, but certainly among consumers would have a very low recognition level. I don't know whether there is evidence for that. While if I say my product is local, people understand that immediately.
Yes, and actually it doesn't mean that if a product is locally produced, it is an agroecological product, of course. Maybe if we run the same questionnaire to producers, maybe the answers will be totally different.
Christopher, in order to be absolutely sure about what you're saying, we have various case studies focusing on all aspects of short, medium, and long value chains, focusing also on different production systems, locally established on a regional or a national or even on international basis, because for many of these countries, agricultural exports is a very, very important means for enlarging, developing their GDP. So if they have the ability to differentiate these products under agroecological terms, we think with the suitable certification measures, we think that we can increase the impact of these products.
You will know that there's really a plethora of labels if you go to rich countries. I mean, I think when I wrote about this many years ago, like 7 or 8 years ago, there were like 300 labels already out there for various features of products. So there's a real problem there about differentiation and then justification. And I'm not sure how that can be overcome. I mean, it's just a...
Look, the problem is that there is a great effort from totally different channels, European Union, United Nations, NAFTA, even. So in order to invest on this specific labeling, we are totally aware, I totally agree with you that this labeling plethora is confusing consumers, but we will try to unify this labeling respecting specific production and processing and marketing practices under pure agroecological terms. Thank you for the comments. They are very, very useful. Okay. Anything else? Any other question? Okay. So we proceed to the next presentation. Dr. Yorgos Kleftodimos will be the presenter, and the title of it is identifying the producing systems in the area of Upper Egypt regarding their crop pattern activities and their linkages to the market. So, Giorgo, you can start.
Thank you very much. I'm working also in this project. I'm working mostly in the modeling part, where we're trying to identify barriers and opportunities in the different case studies for the adoption of agroecological practices. And here is the work that we are performing currently in Egypt. So in general, we are working in Egypt, as all the North African countries, more or less. I mean, they are a hotspot of climate change. They are suffering from several changes, like increasing temperatures, lower precipitations, unpredictable weather. Also, the water resources are rather scarce and unstable, so there are several threats regarding the environment. We have also economic threats regarding the market's instability. We are speaking about Egypt. It's a country that the government is very strong, very short value chains, because mostly the government is the buyer of the most important products, also is the one that is supplying the farmers with inputs like fertilizers. We have huge price variability, and also we have societal problems, because especially after the war between Ukraine and Russia, we have food safety issues, as it's a country that is importing more than 90% of the cereals that is consuming, and the cereal is the basic food for the people. So we can see that their agricultural systems are high. In fact, the resilience of their agricultural system is in threat. So our way is to try to find how we are going to increase the resilience of their agricultural system in external factors such as market stability and climate change. So the last years, agroecology has emerged as a new trend, new fashion, as a new way of producing that may increase the resilience of such fragile agricultural systems. So our work here is to examine the opportunities and barriers of the Egyptian farmers to adopt agroecological practices, and what is going to be the impact of these transitions. So, in fact, here we are searching the key factors that are affecting the decision-making process of the farmers towards the adoption of agroecological practices in order to increase the resilience of their agricultural systems. So, we are working in Upper Egypt, in the governorate of Luxor, which is located in the south part. Is an area with almost 500,000 of residents. The great majority of them are farmers, and they are working in the agricultural lands. We are speaking about a region where the only available water resources is the Nile. The precipitations are almost zero in this region. High temperatures, and also we have very poor population in this area. The majority of the population is under the limit of poverty. The majority are working in agriculture or in tourism, where there are two sectors that are in high competition, especially for the young generation, because the young generation prefers to go work in tourism, which is much more profitable than working in the farming activity. So, how is our methodology? We have established a living lab in this area with all the involved stakeholders from the state, local cooperatives, farmers, extension services. And the first work, it was to perform a territorial diagnosis in order to detect the representative farming systems of the area, to characterize the area with the representative farming systems. Then we collect all the necessary data from questionnaires, and we create a baseline scenario in order to represent the situation as it is now. Through a model, we use a bioeconomic model. I will explain it to you in a minute. And we made, at the first step, we made a multi-criteria analysis in order to see how different agroecological practices may impact their production systems. So our model is called DAPSIM, is a dynamic bioeconomic model, has a bioeconomic component and an economic component. In the biophysical component, in fact, runs in several years. It estimates the yield of the crops by taking into account the use of nitrates, the use of water, water stress, and every year is estimating, according to precipitation, in this area is 0, the water availability, the use of filtrants, it's calculating the yield and the yield variability. And this enters as an input, it's in the farm model, which is a traditional farm model, maximizing the input, maximizing the profit of the farmers, where in our objective function, the profits are not only the ones that are selling in the market, it's also the self-consumption, because the self-consumption is a very important element in these households. And of course, there is a risk relatively to the price fluctuations. And there is a livestock part which is not finished yet, because they have livestock, but the livestock remains rather marginal. I mean, they have 1 cow or 3 goats just for self-consumption, but still they are cultivating some crops in order to feed this livestock. The results. In fact, after the main crops that are cultivating in the area are sugarcane, which is the cash crop. I mean, the big farms that are cultivating sugarcane directly in a value chain to the state. It's the government that buys the sugarcane. They're going to the factories that are belonged by the state. We have wheat, which is a very important crop due to cultural aspects. Every house in this region should cultivate. It's an obligation to cultivate the wheat that is consuming. So it's one of the major crops. We have also maize and sorghum and clover in small quantities, which is mostly for the animals. According to the Living Lab and the different characteristics of this area, I mean, we have an area where they are using as an irrigation system flood irrigation, mostly monoculture of sugarcane and some other crops, wheat, maize, for self-consumption. There is almost no local market. I mean, they're not producing a lot of stuff apart from sugarcane. The land is extremely fragmented, so we're speaking about very small parcels per farmer. So according to these characteristics and the discussions with the local stakeholders, they actually identify 3 practices, agroecological practices. Here we can have a debate if indeed they are agroecological practices, at least is what they perceive as agroecological practices, that they wanted us to examine, which was passing from flood irrigation to drip irrigation, passing to long rotation systems, and to introduce salinity-resistant varieties. So by the use of the model, we perform a multi-criteria analysis in order to see the impacts of this on their systems. So regarding the salinity varieties, we saw that indeed we have savings in water, important savings in water. We do not have significant transaction costs. It's easy to be adopted, mostly because all the seeds are provided by the government. And we have a high effect in profitability. They have more stable yields, higher yields, so we have an impact on profitability. Regarding the drip irrigation, mostly we have significant effect on water savings. We have some costs for the transaction in order to invest in drip irrigation. So mostly the big farms, the cash, that are cultivating the cash crops, they are able to do it, and a medium effect in profitability. And finally, long rotations, and yes, we have water savings, we have a very high effect in profitability, and increased effects in the transaction cost. It's much more difficult to pass in long rotations, because wheat does not easily get out of the rotation systems, because apart from the importance for the household, it's also tradition. I mean, they feel ashamed if they have to buy bread instead of cultivating them. So from our questionnaires and the performance, it was mostly in we identify 4 different farming systems. We have the big players, which is the sugarcane producers, where they have the higher profits. You can see how fragmented are the land. I mean, the biggest farms is 1.5 hectares. This is the biggest farms in the area. The medium players, that they have sugarcane, but mostly wheat and maize, they're around less than 1 hectare. And the very poor farms that they have no access to the market, they're just cultivating for self-consumption, nothing else. And the livestock is still a work in progress because the questionnaires about the livestock has not finished yet. So, in conclusion, we validate, in fact, previous studies regarding the identification. I mean, in these areas, it's the first study in Luxor, but in general in Egypt, more or less, it was the same characteristic. I mean, we have big players, and we have very poor farmers with very fragmented land that they are mostly dependent on self-consumption. We have a very strong trade-off between tourism and agricultural activity. More than the 80% of the farmers there, they do not have a succession situation. Nobody wants to work from the young generation in farming activity. And we saw, at least at that stage, that the agroecological practices have some positive effects on the yield or economic indicators. However, we have not introduced yet clover and sorghum because we have not finished the livestock, so the model is not yet complete. Regarding the main constraints, the biggest constraint is labor, because the new practices is much more labor intensive, and even if they have money to pay, they do not find easily working hands. They do not find people to go to work in their farms, something that is validated from previous studies in the same region of North Africa. So for the future, we want to finish with the livestock in order to introduce it in our model, and to run different scenarios in order to see the opportunities and the barriers to adopt these practices, because now it was just a multi-criteria analysis in order to see, in a scenario business as usual, what are going to be the impacts. So if we want to have a scenario of full adoption, we want to see the barriers and the opportunities of the different stakeholders and the different farm types on these aspects. Thank you for your attention.
Thank you very much, Giorgos, for this presentation. Any questions or comments?
So in your opinion, the inevitable trajectory over the next 15 years is 80% of the population moves to Cairo, 20% stays in tourism, and all the land is converted to robots.
Taking the history of Egypt, Egypt has this tendency where the population becomes extremely poor. Instead of moving it to, let's say, more open space, they just packed everyone in Cairo. So the most probable is that at one point we will have only sugarcane fields, and a part of the young generation will move to tourism, and others they will just immigrate to Cairo. Yes, that is the most probable scenario, if nothing significant.
It's extraordinary because I've read histories of the role of Egypt in the Roman Empire, and in the 2nd century AD, it was raining in August in Egypt. So the climate has changed so much since then. So it's extraordinary, the transformation.
Yeah.
But I mean, obviously that sort of climate is going to drive people away.
At one point, yes. Even if, I mean, last year it rained in Luxor. After 40 years, it was the first time that it rained.
We have exceptions. Okay. Anything else? Any other questions? Okay. Thank you very much,
Thank
Giorgos.
you very much.
And we are moving to the last presentation. It will be online, and it will focus on the methodology being followed for the deployment and development of these living clubs of NATAE. The presenter is Dr. Michael Caulfield from Wageningen University. Hello, hello, Mark. You're muted, probably. We cannot hear you. Can you try on more?
I was muted. There we go.
Now we can hear you and we can see you, and your presentation, you can proceed.
Thanks, George. That's kind. So this presentation will be slightly different to my other colleagues in NATAI, in that we're really presenting the methodology through which we're trying to stimulate agroecological transitions in North Africa, more through the farming side. So perhaps from the other angle. Okay. So with this project, we developed this set of guidelines for the development and establishment of living labs, and they are available. But first, let's start with why living labs. Well, fundamentally, it comes down to the problem that we're all too well aware of. Despite the amount of money, the millions that's been invested in stimulating more sustainable agriculture globally, there's still a big gap between what we know. We already know how to conduct agriculture or farming systems more sustainably, but these practices are not being taken up by farmers. And it's, as I say, it's not about knowledge. It's not even a question about a lack of will. And indeed, in many cases over the long term, it's not a question about economic returns. Over the medium and long term, agroecological approaches tend to be more resilient to economic shocks and are often better from that perspective in terms of returns on investment. I would argue it's a question of how we involve stakeholders in the exploration of more sustainable farming practices, so that the farmers and the stakeholders themselves take ownership of these practices and employ them, not because technicians have told them these practices work, but because they themselves have tested and developed the innovations themselves. And this is what the Living Lab approach tries to achieve. And in recognizing this, the EU has set up a goal of trying to have 100 living labs by 2030. And according to the EU, living labs have three main elements. They have to co-create with a large set of stakeholders. They need to be carried out in real-life settings and involve end users. In NATAI, our living labs provide an innovative governance structure for agricultural research and agricultural systems to identify, test, adopt, and scale up combinations of agroecological practices in an uncertain, and that's an important term, and complex real-life context. As part of the project, we purposefully selected sites for the establishment of living labs in different agroecological zones in North Africa. So we have the oasis zones, cereal plains, irrigated valleys, mountains, peri-urban sites. These represent the 5 main agricultural systems of North Africa. Our living labs are located in 7 locations, 1 in Mauritania, 2 in Morocco, 2 in Algeria, 1 in Tunisia, and 1 in Egypt. I'll give a little presentation or an insight into the living labs a bit later. So getting back to the methodology of establishing the living lab, so we face 2 main challenges in terms of setting the boundaries. The social dimension, so defining the local food system that we're dealing with, but also the geographical delineation, the territorial level, commune level, how that will be addressed. On top of this, and perhaps one of the biggest challenges that we find, is the right balance between co-creation and ensuring that living labs respond to the most pressing challenges in the agroecological context in which they're found. So there's this balance between data extraction requirements and the co-creation elements. As part of NatI, we've found that there are a few key points to creating a well-functioning living lab, creating a representative board. That means ensuring that the different stakeholders are well represented, not just the researchers, not just farmers, but also the other stakeholders that are involved in these sustainability issues within the context. For that, you need to ensure their involvement, right? So they're not just there as window dressing, but inherently and practically involved in the work. This interaction with all stakeholders has to be guided by transparency and informed consent. And knowing and respecting your stakeholders is super important. That streamlines efficient stakeholder interactions. And finally, to do that, it's managing these dynamics. You need to have really good facilitators. This, it's perhaps a big information slide, but it tries to give an idea of the activities that are going on in our 7 living labs within the NatI project. I'm not going to go into the details here, but as you can see, we've got a very packed agenda, or the living labs have a very packed agenda, as they're expected to undertake these activities within the four-year timescale. A lot of work will involve the generation of data, e.g. farming, household surveys, evaluation of policies, characterization of value chains, etc. But there's also very much this focus on farmer experimentation within the living labs themselves. So as I promised, I'm now going to give you a little flavor of the living labs that we've established so far as part of the project. So I'll start with Eitot Man. So Eitot Man is from Morocco, close to Meknes. It's a peri-urban living lab. It's production systems of vegetable and aromatic plants. And the main challenges that they face in that living lab are soil health, high pesticide use, and farmer organization, or a lack of farmer organization. They're looking to develop innovations, agroecological innovations, to address soil health issues through crop rotations, biopesticides, and also they want to help develop farmer organization. Then we have the living lab here of Lagouat in Algeria. It's located in an oasis. The main production system is polyculture, so date palms, as you would expect in an oasis, cereals, forage and livestock production. Water management, and this is a common theme throughout most of the living labs, is one of the main challenges, but also soil fertility and issues like access to skilled labor. They're going to be trialing innovations related to composting, water management, income diversification, the pollination of date trees through different mechanisms. Then, as Georgios had presented in the previous presentation, this is the living lab here in Egypt, in Luxor. It's an irrigated plain. Cereals, sugarcane, vegetables, livestock production are the main production systems. Water management, obviously, as we talked about before, but they also have these other challenges of land fragmentation and the unstructured local markets. Some of the issues that they want to be looking in, as we've seen, is the drip irrigation, saline-resistant crops, long rotations. Moving on to Mauritania. So the Mauritania Living Lab is located in Nouakchott. It's a peri-urban living lab, so the second one of the project. The main production systems are vegetable-based, also with aromatic plants such as mint, market gardens, arboriculture. The main challenge is water management again, soil fertility again, but also, and what we've seen in the first presentations, the valorization of agroecological products, so the market, and the innovations that the farmers are going to be looking into are polycultures, crop rotations, organic inputs, and agroforestry. In the Living Lab in Tunisia, it's located in Siliana, it's in the cereal plains. The main farming systems are obviously cereal-based, with some of them integrating livestock, so mixed farming systems. Climate change, rain, precipitation, changes in precipitation patterns, soil degradation, access to market are the main challenges here. They're looking to address or to trial innovations on no-till practices, crop rotations, intercropping, livestock feed, and again, cooperative engagement. Penultimately, the second Living Lab here in Morocco is located in Skoura Mdaz, so that's about 2.5 hours east of the other one in Meknes. It's in the Atlas Mountains. Production systems mostly focus on olive production with an understory crop, either cereals or vegetable production. Water management, soil health. As I say, these are the common themes running out throughout North Africa. Market access, value chain, infrastructure are important challenges also. They're looking to assess improved organic inputs, intercropping, water management, and again, the valorization of production. And last, but certainly not least, is the Living Lab of Algeria in Tizi Ouzou. It's the second one that is located in the mountains. They have mixed farming systems, again, with olive production and understory production with cereals and vegetables, integration of livestock as well. Their main issues is access to water, but also access to land. So there's an issue of land fragmentation, which is a strong process there. And the innovations they're looking to address in the Living Labs are organic inputs, agroforestry, aromatic and medicinal plant production as supplementary streams of income, and the development of cooperatives. So yeah, I'll leave it there, but hopefully that's given you a little bit of an insight into the Living Labs and the Living Lab approach that we've taken. As I say, it's slightly different to the previous presentations. It's perhaps more of from the farmer perspective. But yeah, if you have any questions, I'm welcome to look forward to answering any.
Okay, thank you very much, Mark. Are there any questions for Mark? Okay, thank you very much for this presentation, Mark, and have a nice day. So we have reached the end of this very interesting, guys, I hope, conference. So I invite my good friend and colleague, Rule Kutsu, to do the closing of the conference.
So, ladies and gentlemen, dear colleagues, dear friends, our conference has just finished. We would like to thank you again for participating. Particular thanks to Professor Samir Mili for his inspirational presentation on the roles of policies towards facilitating innovation and digital transformation in the agri-food sector. We thank also the session chairs and the presenters for meeting the time limits set. We also thank everyone who attended our conference online. We believe we had the opportunity to attend very interesting scientific communications related to agriculture. Especially we thank all who were present at the conference, because except discussions about scientific issues, we had also the opportunity to know each other better and to want to meet again. 76 oral communications were presented and 35 posters with a variety of issues from water management and natural resources to the perceptions of people on new technologies. The authors are from 21 countries and 3 continents. The conference opened on Thursday with 2 sessions that dealt with sustainability and innovation in agricultural production. Systems with positive environmental impact and potential to support viability and economic performance of farms were analyzed, but also a lot of research focused on the views of citizens and consumers. On Friday, we followed the research results of scientists in the domain of livestock and fisheries production. We heard details about the development of digital tools to support farm management, as well as new technologies with positive contribution of farm animal welfare. Now that AGIS constitutes an integral element of the Common Agricultural Policy, a whole session was allocated to training and advisory tools and methods. Research results have reported ways to collect and efficiently analyze data, as well as use platforms and artificial intelligence in order to produce reports and provide advisory support to farmers and other actors across the supply chain. A separate session included research papers on analyzing environmental profiles and preferences of citizens. Different types of analysis and surveys focus on the attitudes of people regarding innovations, initiatives that aim to improve healthy living conditions and protection on flora and fauna. We allocated 2 sessions today with presentations focusing on digital tools. It seems that this is a quite prolific part of research development, with many authors demonstrating their results and how these digital tools can form solutions towards sustainable and resilient production in agriculture, but also in other economic sectors. Many thanks again to you all, and we are looking forward to seeing you again in 2 years in the next conference of HAICTA. It has not yet been decided where it will take place, but rest assured that a very interesting place will be chosen for another time. Have a safe return home. Thank you. Γιώργο, μήπως να πεις για το αυριανό.